Simon Says subscribe and click on the bell icon to receive notifications.
We've made the files the instructor uses in this tutorial available for free. Just click the link below in the video details to get these.
Hello, welcome to the Introduction to PHP Programming course. Thank you for choosing this course. Welcome, and we hope you enjoy the course. So what are we going to do in the course? Well, we're going to learn about PHP, obviously. This is the overarching objective of the course. We're going to get you to a point where you will be a PHP developer. That is the goal. That is the objective of the course. And these are the topics that we're going to cover in the course to get you there. Now, PHP originally was created way back when in 1995 by a gentleman named Rasmus Lerdorf. And when he created the language, he wrote it for maintaining his personal web page, his home page, when the internet was just born in 1995. And since then, the language has morphed and grown and evolved and has become, if not the most popular language, certainly one of the most popular languages supporting dynamic, interactive website construction. But PHP, let's remember, is a server-side language. It is not a language for directly developing front ends. The code that we write in PHP is executed on the server that delivers the web pages to the client browser. And PHP is part of what's commonly referred to as the LAMP stack. This is a very popular collection of technologies for internet development that includes Linux, Apache web server, MySQL for the database backend, and PHP for the programming language on the server side. And with PHP, we can do all sorts of things because we have on the server side access to all of the information that we might possibly need to interact dynamically with a user, to build web pages that provide information that we're storing about a user or about our products or about our company on our database, on our server side. We have access, again, to everything that we might need to create these compelling websites. So if you're not familiar with, again, how the internet works and how the browsers work to display information to a user, if we have a standard static website, as is depicted with the red arrows in this diagram, we have a web server that returns when requested by the client, the browser, somebody sitting in a coffee shop somewhere with a pad or a laptop, requests a web page. That request goes to the web server, and the web server pulls that web page from its directory structure. The web page is completely static. All of the information that's going to be displayed to the user, to the requester, is included on the web page, the HTML page. And that web page, that file, that HTML file, is then returned to the user and displayed by the browser. So we don't have a chance in this scenario to interact with the information that we're passing back to the user because it's all already included on the file, on the HTML file that's on the server. In contrast to that, with PHP-enabled web pages, when a user requests an HTML file, a website file from our server then reads or interprets the PHP code that's embedded within our HTML files, does something. It may request data from a file on the server. It may request data from a database. It may dynamically create the HTML that is then passed back to the client browser for display on their computer. So again, the differences here are that with PHP-enabled websites, we are able to dynamically create content for the user in real time as the user is making the requests from our website versus static HTML presentation, which does not allow us to create any kind of dynamic content. Well, like any programming language, PHP has certain rules for how we write code that can be interpreted by the PHP preprocessor on our server. Those rules, and any rules for a programming language, are referred to as the syntax of the programming language. And PHP didn't reinvent the wheel. I think that the language was very well constructed because it inherited many of the features of other very popular programming languages like C++ and C and Java and so on. And like those languages, one of the most important characteristics of the PHP language is how it ends or terminates a statement. And just like C++ and C and Java and the others, when we want to tell the PHP preprocessor that this is the end of a statement, we must end that statement with a semicolon. And as a beginner, you should expect that this is probably going to be the most common error that you're going to encounter while you're writing PHP code, is remembering to put that semicolon at the end of a statement. PHP preprocessor is pretty forgiving about providing decent error messages to point you to that forgotten semicolon. Well, like other programming languages, PHP has a set of special words. In the syntax of the language, we have these key words, these special words that have a meaning to the language. They have some kind of defined behavior the language expects from when we use these keywords. This is the list of the keywords, and as we go through the course, we're going to visit pretty much all of them. So don't be intimidated by the list. It's actually a small list by programming language standards of keywords. Again, we will cover most of these through the course so that you'll naturally become familiar with them. So the PHP language, again, is a way to embed dynamic content or interactive content within an HTML page so that the user gets a more dynamic experience from a website. Well, because the PHP code is embedded within HTML code, we need a way to identify the PHP code for our web server, for the PHP preprocessor on the web server, to recognize the PHP code and execute it and provide the content to the user's web browser in the form of an HTML page, because in the end, the user browser really only understands HTML. So the embedded PHP is never seen by the user. It's converted by our PHP preprocessor. And when it's passed to the user's computer and displayed on the browser, the only thing the user sees is HTML. And this is quite a contrast to some of the other scripting languages that provide dynamic content in websites, because, for example, JavaScript is actually embedded within the HTML and therefore can be seen by the user in the HTML source code on the browser side, on their side of the transaction. So again, we need this PHP tag to embed our code within the HTML, and that PHP tag is as it's seen here. It's a less than sign, question mark, PHP to identify that it's PHP code scripting, and then to end that tag, it's a question mark greater than sign. The short form, and there is a short form, eliminates the PHP letters. This is not considered best practice because some of the preprocessors may not recognize the short form, so it may limit portability of the code. So we try not to use the short form. It's 3 keystrokes, so just include the PHP within the beginning tag. So not to spend too much time talking and not getting into what we're all here for, and that is learning PHP. We're going to start with a very simple program, and this is the Hello World program. And Hello World is the quintessential I'm learning a new language kind of a program. Way back prior to even the C programming language, the myth is that Kernighan used a sample program with the B programming language, again, the predecessor to C. And that simple program to demonstrate the B programming language was to print Hello World. And so ever since then, anyone that's learning a new language, anyone that's teaching a new language, generally starts out demonstrating basic syntax of the language with the Hello World program. So here it is in PHP. Again, this would be embedded within an HTML document. So within an HTML document body tag, we have this PHP code snippet, this piece of script. And you'll notice again the beginning tag that identifies for the preprocessor this is PHP code, that this is the beginning of a PHP code section. Then we say echo hello world, and all this is doing, the echo command just sends that text, that string, into the HTML document. It just echoes it, it prints it out. And then we have the end tag. And notice again that we have the semicolon at the end of the echo statement. This marks the end of the statement and is absolutely required. Okay, so for our sample program, our example of the Hello World PHP program, I'm running this on a 2008 R2 Windows server that's running Internet Information Services 7 web server and with the PHP preprocessor installed. So this demonstrates the versatility of PHP in that this code, this very web page, will easily execute or be displayed from an Apache server, as it is here with the IIS server. In the PHP file, in the HTML code, this is all standard HTML document header, and we won't discuss that. But within HTML body tag, we've embedded our PHP code. And you can see with the PHP opening tag and the PHP close tag, and then within that I have a single PHP statement, echo hello world. And notice that my code is well spaced, it's easy to read, it is well commented. This is what the style of code that you should try to attain. Something that's easily readable and is well documented for anyone, including yourself, to come back to 3 months from now, 6 months from now. You've forgotten what you've written. So you need some way to easily be able to get back into the rhythm of the code and potentially either add to it or make changes to it. And all of that is simplified with some good commenting. So we've got this file. I've named it PHP course _ example 1. Notice .php. This is a PHP file. Contains HTML, but we need to signal to the PHP preprocessor that this file needs to be, there's something in this file that needs to be translated, and this PHP needs to be rendered into HTML for transmission to the browser. So I've saved this, and I come over here to my Firefox browser, and I went to, again, this is all local for me, so I'm not on a hosting environment, although I could be. I'm not on a hosting environment, so I go to localhost, my directory under the web server, and the actual file that I want to display. And there we go. We get our hello world. Again, this is the proof of concept for you to be able to, not necessarily that it's a challenge to write the PHP code, but this first exercise that you're going to do, that this example sets forth for you, is the ability to transfer the PHP file to a web host, to a web server that has a PHP preprocessor that will take that file and render the HTML that can be displayed in a web browser. So how do we go about creating these HTML files? Well, however you're doing your HTML development now, you can continue with that. Most of the development environments, especially the commercial ones, will recognize PHP code within an HTML document. And for the paid development environments, Dreamweaver and some of the others, the feature sets differ wildly. So you can pay hundreds and hundreds of dollars for a development environment for HTML, PHP development, or you can pay nothing. There are many open source IDEs. We refer to the development environment as an integrated development environment. There are plenty of open source options that you can choose from. I leave that to you to explore, but minimally, a PHP developer really only needs a good text editor and a way to move the files from your development environment onto a host that has a PHP preprocessor and a web server and can be queried for the web page by a client. And that's it. That's all you need. So I like to do my PHP development with Notepad+. It's as simple as that, and a simple FTP client that'll push my file onto the server, the host server. Now, another thing that's really important, just to suggest a best practice, is that PHP, like many languages, ignores whitespace. The extra space in our programs is ignored. It has no meaning to the language. So there's therefore no reason not to have your code well spaced, indented, making it easier to read. And that's the key, making it easier to read. And then within that, to have some explanation of what your code's doing and where that explanation can be completely ignored by the PHP processor. We refer to this as commenting the code. And in PHP, there are two styles for commenting code. One is a comment that goes from the comment mark, to the end of the current line. And the other style is a comment that marks a block of lines, or even a single line, but marks a block of lines. And you see those there, the // from wherever that is on a line, the // will cause the PHP preprocessor to ignore anything that comes after that until it reaches the end of the line. And then the / splat and splat / would mark some grouping of lines, and potentially even just a single line, as a comment to be ignored by the PHP preprocessor. So to get you some experience, and mostly to get you to demonstrate and to prove that to yourself that you can create an HTML file with embedded PHP, move that onto a web server, and then display it on your browser, we have our first exercise. And in this exercise, we'd like you to create a HTML page, a web page, that contains the PHP code, and in that to display or echo your name. Say, hello, whatever your name, welcome to the world of PHP. It's just a simple echo command. Then transfer that file onto your web server and call that file from your browser to display it from your web server. Now remember that when you're writing this exercise, that your file will not end in HTML. We need to tell the web server that it needs to pre-process this file with the PHP preprocessor. So your file, what used to be your HTML file, will now end in .php. So good luck.
For the next section, you'll want to download the course exercise files. Click the link below in the video description to get these. You can also scroll through the details to find timestamps for each section in this course. If you're enjoying this training, please leave us a comment.
So a variable is really nothing more than a storage place in memory where we can put a value. That storage place gets a name so that we can easily get that value back out of the memory and use it in our code. And unlike other programming languages, we don't have to deal with the memory location, pointers, we don't have to deal with memory addresses. The PHP preprocessor, all of the plumbing that makes the PHP language, does all of that for us. So here I'm demonstrating how to create a variable that's going to store a number. So I give it a name. The name of the variable is integer variable, and I put the number 42 in that variable, in that memory location. Then I create a string variable, and I put a string in that memory location. And then likewise with a decimal value, I call it double variable. That's just a name. And so in memory, I get 3 locations in memory, 3 storage places. Each of those storage places contains the values that I asked PHP to put there, and it has a name associated with that storage location, so that in the next set of code, I'm using the echo statement, I can go to that memory location and retrieve that value with nothing more than the name that I gave it. So I'm echoing the integer variable, I'm echoing the string variable, and I'm echoing the double variable. In PHP, unlike other programming languages, PHP variables are loosely typed. That means we don't have to tell PHP the type, the data type that we're going to store in a variable. Again, much of the abstraction here of the memory management done by the PHP preprocessor is what makes PHP such a popular and powerful language. In this case, again, I've created those 3 memory locations, those storage areas in memory, with the names integer variable, string variable, and double variable. Those values that I assign went into those memory locations. But then down below in the second set of assignments, I put the number 42 in the memory location that was previously storing the string value. Then in the integers, those memory locations I was using in the integer variable to store a number now is storing a string. And the same thing with the double variable that I had created that was previously storing a decimal value is now storing a string value. And I've done nothing but assign values to those memory locations. So this demonstrates how PHP handles for us the data typing that we would otherwise have to do ourselves in other programming languages. So we can put values in memory that are of this type, recall those values using the integer name or using the variable name. Then we can store something else, a different type, in that same memory location. Using the same name we had used to store an integer, we can now use it to store a different type. So this makes PHP amazingly flexible in the way that we can deal with and manage our variable data. So let's go look at some code. Okay, just to demonstrate the PHP code that created the variables, here is the little code snippet that we saw on this slide. Again, we're creating 3 variables. One variable that's going to store the number 42, another variable that's going to store a string, and another variable that's going to store a decimal value, and the names associated with those variables. So this is our code, and I come over to my Firefox and load that page, and I get those values generated by the echo statement, that the variable integer value was storing the value 42. The string variable was storing the value I love this course, and the double variable was storing the value of pi to 5 digits. So pretty straightforward. We create the variable, we create the storage area in memory simply by executing this statement. The PHP plumbing, the underlying abstraction layer in PHP, does all of the hard work for us in going out and getting the memory, making sure it's the right size, getting the address of the memory, putting that value in the memory, and then down here, allowing us to retrieve that value simply by using the name. So very straightforward. And then to further demonstrate the flexibility of the variables in PHP, here again we have our variable creation with the three variables that are storing, again, an integer, a string, and a double value. And we print those out. Then I put a break here, a delineator, and I wanted to demonstrate how the loose typing of the PHP language makes this use of variables so easy and flexible for us. So I take the variable that was here storing a string, and instead I decide, I'm tired of storing strings in here. I'm going to store a number. And where I was storing a number, I'm now storing a string. And so let's see how this works in our preprocessor and pass through to our browser. So here we go. Refresh the window, and we get these are the initial values in the variables. Here's my break line, and then here is the values from the reassignment into those same variables. So you can see again the demonstration of the flexibility of the loose typed variables in PHP. Okay, just to beat this horse to death, let's just reiterate that in PHP, variables are loosely typed. That means we do not have to tell PHP the type of the data that we're going to store, nor do we have to store the same type throughout the life of the variable. But there are some rules. There are some rules to using variables, and the rules are these, that all variables must begin with the $sign. The name that comes after the $sign must begin with a letter or an underscore. So for example, the variable named $2 variable is not allowed. It will generate an error because it begins with a number. And the names of the variables are limited to the characters A through Z, the numbers 0 through 9, although they cannot begin with the numbers 0 through 9, and the underscore. And it's important to remember that variable names are case sensitive. So uppercase and lowercase mixed in the variable name results in two different variables because they will have two different names based on the upper and the lower case. So how do we create a variable? Well, we don't. PHP does that for us. The plumbing, the underlying abstraction layer of memory management, of variable management in PHP allows us to just not even have to pay attention to that. So to create a variable, all we have to do is create a variable and assign to it in our code. So it's as simple as $sign my variable equals 42. When the PHP preprocessor sees that, it will create a variable in memory that will store the number 42. And then we can, wherever in our code, go back and recall that value 42 by using our variable name. But variables have lifespans. They have an area within the code in which the variable is accessible. And so with PHP, there are three scopes to variables. We call this scopes. The lifespan, the area within which the variable exists and can be accessed, is referred to as scope. Local scope is you create a variable in a snippet of code, and that variable is accessible and exists within that snippet of code. A global variable is accessible and exists throughout the code. And a static variable, which is a variable that does not change, its value does not change. So we're going to do an exercise now to demonstrate some of these variable techniques. We're going to create a web page that has PHP code to display hello, whatever your name is, welcome to the world of PHP. Now, instead of just typing your name there after the hello, we're going to use a variable to store the value of your name. And using that stored value in the string in the echo statement, and then load the web page onto the server and display it in the browser. Now again, this isn't amazingly complex piece of code, but it does demonstrate the basic syntax for creating a variable by assignment and then using that variable in the code. And as we move forward and we gain more confidence and comfort with our, number one, our environment, and number two, with PHP code, the exercises will increase in complexity. Okay, so welcome to the PHP community discussion, language lawyer debate about the virtues of echo versus print. The functionality, what these two commands do, is identical. They will both take what is passed to them and process it through PHP and out into the generated HTML. The print command, however, is a function. We don't know about functions yet. We will. But as a function, it can only take a single parameter, that is, a single value to act upon. Whereas echo can take multiple values. And so in the little code snippet here where I say print, this is a print statement in a single string, is the limit for the print command. You must give it a single parameter. But the echo command, I can give it a set of strings. So echo, this is an echo statement, is actually passed to the echo command as 5 separate strings delineated by commas. And the echo command interprets this and spits out the single output, this is an echo statement. Now, to be fair to the print function, we could do the same thing using the concatenation operator, the dot, the period, where this adds strings together. And because the precedence of this operator is higher than the function call to print, the 5 strings, this is a print statement, they will be added together to create a single string that is then passed to the print statement. So again, functionally, print and echo are identical. Use one or the other, it really makes no difference. Now, when you get out into deeper commitment or a deeper involvement with the PHP community, you're going to hear arguments about echo being faster. Under extreme loads, because you're not going to find it in everyday use, and there is no evidence that it is faster in everyday use, but under extreme loads, there has been published experimental results that suggest that echo is about 18% faster than print. But again, that's not an everyday usage. It was under extreme loads. So anyway, my opinion is use one or the other. It really makes no difference, whichever one you're comfortable with. But anyway, welcome to the debate. So a more serious consideration is single versus double quotes. Single quotes will not interpret any values or special characters that are contained within the quotes. The common description of a single quote is that it represents whatever's in it as is. Whatever is enclosed within the single quotes is represented as is. There is no interpretation. Now, this is in contrast to the double quotes, where if we insert a variable name within the double quotes, the PHP preprocessor will interpret that variable name, go to memory, get the value that's contained in that variable, and put it in place of the variable name inside the double quotes. Likewise with special characters such as the new line character or the tab character. Those will be interpreted within the double quotes, but again, not within the single quotes. So let's go look at some code. Okay, so just a quick demonstration of the differences between the single quote and the double quote in our PHP code. So here's a little snippet where I create a variable, and in that variable I am storing the value PHP. And then I have an echo command that is, and using single quotes, saying I am learning, and then the variable, my variable. Then I have a break, and I again use an echo command, and this time the double quotes, and I say I am learning my variable, the variable, my variable. And so let's see how this prints out in our HTML. So again, I saved this. Again, my environment is probably different than yours. I saved this locally because I'm running on a Windows 2008 R2 server with IIS installed and PHP configured, a PHP preprocessor configured. So running this locally, I reload the page, and you'll notice that the single quotes printed the string as it appears in the code. It did not interpret the variable, my variable. It did not go to memory. It did not go and get the value that was stored in that variable. Instead, it printed what I put in the single quotes as is. And in contrast to that, in the double quotes, where I have the variable called in there as well, but in this case, the double quotes tell the PHP preprocessor, hey, interpret this variable for me. Go get its value and put that value here instead of the variable name. So operators give us the ability to manipulate values within our code, within the application. Those values could be stored in variables. They could be actual values, what we refer to as literal values. So an actual number, a string, some value that's already hard-coded into the application. Now, I don't recommend ever putting hard-coded values in an application. It's a maintenance nightmare. But the point here is that operators can act on variables or literal values. So 42 plus 3, using the addition operator, the plus sign, is going to give us 45. If we added two variables together that held those values, it's going to give us 45. There's a huge number of operators in PHP. Not to worry, they're all very intuitive in their use, and we've already seen two of them. The assignment operator, the single equal sign, says take this value and assign it to this variable. We've seen that. And we've also seen the string concatenation operator, which is the dot, the period, that says take this string and add it to this other string to make one big string. So we should start building some comfort level in operators as we review those that are available to us from PHP. So the first set of operators are the arithmetic operators from grade school: addition, subtraction, multiplication, division. The one here that might not be familiar to everyone is the modulus operator. The modulus operator returns the remainder of some division. So in the example here, we have 57 divided by 10, or 57 modulus 10. What that says is 10 goes into 57 5 times and then leaves a remainder of 7. And so modulus returns to us that value, 7. What's left over after the division of 57 by 10. This can be very useful in different situations, and we'll see where those are. Some of the comparison operators. Now, pay particular attention here to the equals to operator. It is not the assignment operator. This is a very common logic mistake. If you're looking to test that two things are equal, then you would use the equal operator, which is the equal to operator. And this is going to return a true or a false based on the values that are being compared. If by mistake, and it is again a very common mistake, if by mistake, when trying to compare those two values, you used an equal sign, that's always going to return a true. always. So you'll have a logic error, and based on my experience, you'll look at that error and you'll know something's wrong in your application, and you'll search for that error everywhere in the code. And after hours, the very last thing you'll recognize is that you used a single equal sign, the assignment operator, instead of the equal to operator. And then notice we can negate the equal operator with the bang, with the exclamation point. So exclamation point equals says it's not equal to this. So this is not equal to that. That returns a true. If it is equal, then it would return a false. Now, in contrast to that, the identical operators. What this says is not only are the values equal, but are the types equal. So is this an integer? Is that an integer? Are both of their values 1? In that case, identical would return a true. And notice again that identical is equals, equals, equals. 3 equals signs. And then again, we can negate that with the bang. And the other operators should be familiar to everyone: less than, greater than, less than, equal to. What's important to note here is that any of these operators, even the negative operators, the not equal to and the not identical, can be negated because we have a not operator. The bang, the exclamation point, is the not operator. So we could take two values and say, are they not equal? Which would mean they're equal. So this can be, if not well documented and clearly written, the operators can get out of hand and become very confusing in the code, making the code very difficult to maintain. So the logical operators here, in addition to the not operator, the bang, allow us to combine different comparisons. So we can say, are these two values equal? And are these two values equal? Or we can say, are these two values equal? Or are these two values equal? And then we could also say the more esoteric XOR, where only one value could be true or false, but not both. Unlike the OR operator, where if either or both of the comparisons returns true or false, depending on your comparison, the OR operator returns true. We'll see examples of these. So now there's shortcuts. Like every programming language, there are some very common things that we do. So those things, we need to give ourselves shortcuts for doing them. One of the very common things we do is that we add or subtract or multiply some value by some other value and then assign that result back to the variable that we're multiplying or adding or subtracting. So rather than writing out a equals a plus 2, we can just say a plus equals 2. And that's just shortcut. It's not a different operator. It's exactly the same operator as adding and assigning. It's just a shortcut. So if you're not comfortable with these yet, then don't worry about it, because you can do functionally identical things with just using the plus, minus, divide, multiply with the assignment operator without using the shortcut. One of the things that we do a lot, especially as we'll see in controlling loops, is adding a 1 to a value. And so there's a very short shortcut that we use for that. And again, we could just say, in this example, we could say my variable equals my variable plus 1. That would be identical in functionality. But we do this so often that we want a shortcut. So if we say my variable plus plus, that is the shortcut for saying my variable equals my variable plus 1. The alternative, obviously, is my variable plus equals 1. So even a shorter shortcut. Now, having the plus plus or the minus minus subtracts 1 from the variable. But having them at the end of the variable name says, hey, use the value that the variable currently has in whatever you're doing, and then add 1 to it or subtract 1 from it. But use the current value first. Putting the plus plus or the minus minus before the variable name says, hey, change the current value first. Either add or subtract 1 from the current value and then use it with whatever it is that you're doing. So these, again, these are shortcuts. If you're not comfortable with them right off the bat, it is not a big deal because they mean exactly the same thing as saying my variable equals my variable plus 1 or my variable equals my variable minus 1. So these are, again, just shortcuts. So operator precedence, a fancy word for just saying when will something happen? Well, the programming language, like PHP and like all programming languages, define an order in which the operators will execute. And this is the order. So the first thing that ever happens is the increment decrement operators, and then the negation operator, the bang, the not, and then the others in the list as you see them here. Now remember that precedence, the order that things execute in or will be evaluated in, can be overridden with parentheses. No matter what the defined order of precedence for an operator is within PHP, we can override that by the proper placement of parentheses. One of the common examples of this is, what if you wanted to add 3 plus 4 and multiply it by 3? What would we do to ensure that 3 plus 4 times 3 would actually equal what we wanted it to equal? Because the way it's written right now, we're going to get 15. That may be the value that you wanted, but it may not be the value that you wanted. What I really wanted was the value to be 21. So I wanted to make sure that the 3 and the 4 get added first, then multiplied by 3. Because otherwise, the natural operator precedence will force the 3 and the 4 to multiply and then add the 3. So the 3 times 4 is 12, plus 3 would give us 15. That is remarkably different than the value that we were looking to get. We're actually looking to get the value 21. So again, by paying attention to precedence and overriding where we need to by placing parentheses, this will ensure that things are done in the order that we want rather than the order that's defined by the language. So everything in a computer application executes from the beginning to the end. That's great for simple, trivial applications, but in more complex applications, we need to branch the code. We need to execute a certain part of the code if this condition is true. We need to execute another part of the code if that condition is true. This is called branching the code. And we do that by controlling the flow of the code. And that in PHP is done with an if statement. The simplest form is done with an if statement. If this user is a returning customer, then do this. If it's not a returning customer, then we just skip the code inside of the if block. But notice that we have this block of code that we're controlling the execution of. Everything within the braces of the if block is code that will only execute if the condition of the if is met. So everything after the if gets executed as normal. So the if would flow, and everything, whether it executes the if block or not, everything beneath the if block will continue to execute as normal. Well, what if we had multiple conditions for the same situation? So if the user is a returning customer, then do this. If it's not a returning customer, then I want it to do that. I want to go to the login page, or I want to go to the become a customer page, register page. So I could do this with this construct to control the flow of execution, if else. And notice again the braces that are marking these blocks of code that will get executed based on the condition. So if something is true, and again, we could negate that. So if something is false, whatever the condition is, if that condition is met, then the code within the if braces will execute. If it's not met, then everything within the else block braces will execute. And then once either of those execute, one of them is going to execute. Once one of them executes, the code following the if construct executes. Well, what if we have even more conditions? Well, that's the if-else-if construct. And so we can have these stacked as deeply as we need to catch every possible condition that exists for making decisions within the application. There is no limit to the depth of the if-else-if statement. One of those three, and it could be 30, but one of those three in this example, one of those three blocks of code is going to execute. Either the first condition is satisfied and that first block will execute, or the second condition is satisfied and that block will execute. And by default, if none of the conditions are met, then the else block will execute. Well, this can get very messy. So there is a school of thought that says that the switch statement is a cleaner approach to having a test for multiple conditions rather than a deeply nested if-else construct. That's arguable because they both do exactly the same thing. Functionally, they do exactly the same thing. So again, this is one of those PHP program language lawyer kind of debates where which one is better. Neither. Functionally, they are both exactly the same. Here we have the switch statement that has some value, a variable. And then we have all of the case statements. So then the switch construct takes the value that it's given and compares it to all of the values in the case statement list until it finds one that is true. When it finds that true value, it executes the code block beneath that case statement. And if none of them are true, then it will execute the default code block. So it's a nice construct. I wouldn't argue against using it. I'm just saying that if you're more comfortable with the else if else, then use it. If you're more comfortable with the switch, use it. Functionally, they are identical. Okay, let's go look at some code. Okay, so we're going to look at the if, else if, and the switch statement. And here's just a little web page that tests for the value of this additive statement, 3 plus 2. And notice that I've put parentheses around there. It wasn't necessary to put the parentheses, but again, I want my code to be absolutely clear in what I am trying to do. In this case, I want to add 3 plus 2, and then I want to compare that value. I want to say, is the value, the resulting value of that addition equal to 5? And if so, then I would like to print, I would like to echo this statement. Then I do a series of tests using an if-else-if construct where I ask the same question, only this time I ask, is 3 plus 2 equals to 1? Well, that should never be true, so we should never get this line of output. Same thing with 3 plus 2 equals 2. That's never true. We should never get that output. But we drop through one if, an else if, and then we go to the third else if. And in this third else if, 3 plus 2 is equal to 5, so we should get this statement. Now we do the same thing with the switch statement. And in the switch statement, I ask the question. I say, take this value, 3 plus 2, and check it against all of the defined cases within this switch block. Again, notice the blocks. I just want to point this out. These are braces. So each of the if blocks is defined by a brace. The else if is defined by a brace. The switch block is defined by a brace. So we ask, in this switch block, look at the value of 3 plus 2, do that math, take that value and compare it to all of the case statements that you have and execute the code associated with the case statement that matches that. Well, 3 plus 2 does not equal 1, does not equal 2, does not equal 3, so we should never get any of this code executed. So we don't have a match. So we say, okay, well, the default output that I want you to give is down here. So if nothing matches, this gets executed by default. And certainly here, let me reload this. So certainly here we see it in our first if statement. We get 3 plus 2 does equal 5. Then we have this if-else if construct, and 3 plus 2 equals 5 here as well, so the universe is in balance, and we're in the second if statement. But then down here in the switch, we did 3 tests, none of which yielded a true, none of which satisfied the condition. Therefore, we dropped into the default statement, and that is what we got in the output. So everything worked as expected. You can see that the if-else if construct, we could have added an else statement here, and in this else statement we could say echo there is no match in the if-else if blocks. We could say that, and then we could change this so that there is no match, and let's execute that, and you can see the change that there is no match. So by adding this else statement, this final else statement, we failed the blocks here from the if, this else if, this else if. Then we go, as a default, we go to this output in the else. So that mimics the same behavior in the switch statement. We do tests, we fail them all, we go and drop into a default execution branch. So as you can see, functionally these constructs are identical, and it comes down to style and preference. So when you get out into the PHP world and you start debating echo versus print, you can add to that debate if, else versus the switch case default statements. Okay, so we're going to do an exercise where we're going to create a web page that's going to test a username and password. Let's store the username and password in variables in the code, and then test those passwords against the values Kirk for the username and prime directive for the password. If the values match, then print this string, live long and prosper. And if they don't match, then please try again. When we're creating an application, we often have the need to repeat the execution of a block of code, a set of statements. And to do that in PHP, we have three looping constructs. These looping constructs have some control condition that counts and terminates the loop based on the number of iterations or some other consideration. The while loop uses some condition that resolves to a true or a false. And as long as that condition is true, the block of code that's controlled by the while loop will continue to execute. So within that block of code, we must set the condition that will terminate the loop. Otherwise, the loop will run infinitely because the condition will always be true. Now we do that sometimes on purpose, that we have this infinite loop for event handlers and other special conditions. But generally, if you're trying to iterate over a block of code, you're going to want to do that for some set amount of time or for some set count. So the while loop, again, requires that we control that looping condition from within the while block. The for looping construct has the definition of the loop control in the call. So when we create a for loop, we have to give it a starting value, we have to give it an ending value, and we have to give it the increment by which it's going to count the number of iterations through the code block. And then the for each looping construct is a specialized looping construct that keeps count for itself. So we give it a collection, an array, or another collection of items that it will keep track of how many items it has to loop over and perform whatever's in the block of code. Now, once we're inside a block of code, we want to keep that control. So we can set the looping variable in a while loop to terminate the while loop whenever we want inside of the code. But under some conditions, we want to leave the loop altogether. And we do that using the break statement. So if we have the break statement under some conditional control construct, like in the example here with an if statement, when that value in the if statement resolves to true, the break statement will execute. The break statement says, just terminate this loop and get me out of here. And when it says get me out of here, it takes us to the next line of code following the close of the loop block. But it terminates the loop. The continue keyword, on the other hand, terminates the current iteration, keeps you in the looping construct, but just terminates the current iteration. So let's see how this works in code. Right, so in these little code snippets, I wanted to demonstrate the three loop constructs. I want to show you the first while loop. And notice that in the while loop construct, we need to define the loop control variable. Outside of the while loop, outside of the while definition, we need to have some control variable. In this case, I've called it counter, and I've initialized the value to 0. So now inside of the test for the while loop, the condition that's going to control the loop, I just ask the question, is counter less than 10? And as long as that condition is true, the while loop will execute, and in this case, will simply echo a statement that includes the value of the counter as we're going through the loop. Then notice that it's critically important to remember that somewhere in the loop, you must set the termination condition. So in this case, I'm incrementing counter by 1. Counter plus plus is the shorthand for saying counter plus equals 1. We could have written this any of these three ways. Counter plus equals 1, that would have worked. Or we could have said counter equals counter plus 1. Either of those would work. They do exactly the same thing. I choose the shorthand whatever you're comfortable with until you get comfortable with these combination operators. Just use what makes you comfortable. So the key here with the while loop is that we have to set the control. We have to define the control variable. We have to set the control condition, and then we have to increment or change the control condition so that at some point the while loop will terminate. In contrast to that, if we look at the for loop, inside of the for loop construct, we're actually defining our control variable, we're testing the control variable, and we're incrementing the control variable. And all of that happens on one line of code versus on the while loop having the initialization, the test, and the incrementation in separate parts of the code. Easy to forget one of those, and typically the thing that's forgotten is the increment, so that the while loop never terminates. So from that perspective, I'm in favor of the for loop. But again, it's a stylistic decision because functionally they do exactly the same thing. So in this case, for the for loop, I'm just printing out another line of code with the counter value as it's going through the loop. And now we haven't talked about arrays yet, but just accept that we're creating an array here that has the values. An array is a collection of values that contain the values 0 through 9, just the integer values 0 through 9. And then the for each loop says, take that collection of values, call that collection of values num, and then print each of those num values. And when you're done, when you're at the end of the collection, just terminate the loop. So this is a very nice, when we have collections, this is a very nice looping construct because it controls itself. So let's run this and see how we do. Let me just reload the page because I've already run it here once. So I reload the page and we have the while construct counting 0 to 9. Notice that it's less than 10, so we never do the number 10. Same thing with the for loop, and then for the for each loop, we're counting through elements, the values that are inside of the collection, and those values are 0 through 9. So just to show you how simple it is to forget to control the loop construct, in the while, I'm just going to comment this out, save it, and we're going to rerun this, and you'll see that it's not loading. It's not loading because on the server side, we're stuck in this while loop. It will never terminate. Notice that now we just got a dump from the server. All of the values are 0 because the counter never increments. And so this condition, while less than 10, will always be true. And so we have no way of terminating the while loop, and it will run forever. And in this case, lock the browser and the server. Okay, so after having to restart my browser because of the while loop running infinitely, I've done that. And I'd like to talk about the loop termination, the actual loop control keywords, continue and break. So what I've done is I've set up a for loop that will count to 100. Inside of that for loop, I'm saying when the value of the counter is equal to 42, break. What break is going to do is kick us out of the loop, completely out of the loop construct. Not just the iteration when the value is 42, but out of the loop construct completely. And in contrast to that, with the for loop here, so identical for loop counting from 0 to 100, I'm saying when the value is 42, I'd like you to continue. Well, what that tells the loop to do is when the counter value equals 42, stop and just go to the next value. It doesn't kick us out of the loop, it just kicks us out of the current iteration. So let's run this And this is the for loop with the break statement. And you'll notice that the break statement executed at the counter value equals 42. So the last value that got printed here by the echo statement was 41, because when we saw the counter value 42, we terminated this loop and left it. In contrast to that, with the continue statement in this loop, what we're missing is the number 42. Just the number 42, because what we said here was when the counter value is 42, just skip this iteration. Go to the next iteration. So go to 43. And sure enough, that's what it did. Went to 43. So that's just how easy it is. We can control the iteration of a loop with the counter values. We can control when to terminate the loop abruptly if we want to with a break statement, or to control the iterations of the loop based on some value with the continue statement. Okay, so now it's your turn with an exercise. What we'd like to do is create a web page that is going to print the values from 0 to 10, but in reverse order. Use a for loop to do this and print them in reverse order. Then use a while loop to print the square of the while loop control variable, the counter for the while loop. In a perfect world, our code would run correctly the first time and every time. Unfortunately, in anything but the most trivial applications, this is never the case. So we need a way to see how our code is executing, what the values of variables are through the execution of the code, what's the path of the code that's being executed. And most importantly, we need to see which errors, if any, the PHP preprocessor is throwing during the execution of the code. Now, on a development server, we would want to ensure that the display errors configuration setting in the PHP any file is set to true, and that the error reporting is set to report all errors. You can check this setting on your development server using the PHP info call. This is going to dump all of the configuration settings of the PHP preprocessor. You should never turn on the display errors, error reporting all on a production server. I think that should go without saying, but just in case, let me make that clear. That should never be the case on a production server. So some of the common errors that we're going to see in our PHP code is a missing semicolon, or a missing closing brace on a code block, or a misspelled variable name. A logic error that you might see, as we've shown as we were talking about the control structures, is using an assignment operator instead of the equals to operator. Because again, remember that assigning a value to another variable will always return true. And so your code block that you intended on running based on some condition will always run, which may obviously not be what you intended. One of my favorite ways to debug code is to scaffold the code with echo statements embedded within the key parts of the code. So I can review values of variables, I can see the flow of the code, and I can control that with an if statement using a global variable that will only trigger while I'm debugging. And then I can turn all of those statements off and have them ignored by the preprocessor when I push the code to the testing group or to production. On the other hand, there are some very good debugging tools that are available that allow you to step through your code line by line and watch the variable values as they're being assigned in the code. So let's go look at an example of scaffolding code. Okay, so I've got just a little snippet of code here. This is a demonstration of how I scaffold my applications. This is the code I use to do the scaffolding. I'll put this little snippet of code throughout the application where I need to see either where the application is in the execution, or if I need to see the value of a variable. So I start out with variable named debug, simple, and I set that variable to 1, which is equivalent to the Boolean value of true. 0 is equivalent to the Boolean value of false. So when I put that in an if statement, I say if the debug value is true, or 1, then execute this code block. And I can see the state of my program. I can see where it is in the execution. I can see what values certain variables have. Anything I'm interested in, I can spit it out here in an echo statement. And when I set this value, this debug value, to 0, then all of that code is ignored. The if statement would fail, and all of the code inside of that code block would fail. So I can easily put this throughout my program and have no impact on the user when I turn the debugging off, but when I'm trying to see the execution flow or the value of variables in the program as it's executing, I can just set the debug value to 1 and get all of the output that I need. Let's execute this, and I'll just reload this page, and we'll see that the value is printed. Now I'll reset this to 0, save, and run this page, and that block of code is completely ignored by the PHP preprocessor. An array is a data structure. An indexed array is the simplest of the array data structures. An array stores a collection of values, any number of values. The only thing that limits the amount of data that the array can store is the memory in the computer. And the indexed arrays use a number to identify the position in the array where a value is stored. We get 3 types of arrays with PHP: the simple indexed array, associative arrays, which are often referred to as dictionary data structures, and multi-dimensional arrays. So an array can store an entire list of values, and we can access those values randomly. And when I say randomly, I mean that you can say, give me the value at position 6, and you don't have to go from position 1 through 5 to get to position 6. You go directly to position 6. This is called random access storage. And so in the example here, I have an array of sci-fi characters. Notice the keyword array. So that says assign to this sci-fi characters variable an array that's storing 4 strings. An array begins its indexing at 0. What that means is the maximum index of an array is 1 less than the number of elements that it's storing. This is, again, one of those junior programmer issues that often arises, where if you try to access an element that is outside of the bounds of the array, you'll get a fatal error. So how do we know what's in the array? How many elements? Well, we just ask the array. We have a function called count, and we pass it the name of the array variable, and it will return to us the number of elements in the array. Now, oftentimes when we're debugging, we want to see what's in the array. The print_r function will just simply dump everything that's in the array. Well, now associative arrays are like a dictionary. Think about Webster's. When you're looking up the definition of a word, you look up the word to find the definition. This is how an associative array works. Again, by another name, an associative array is known as a dictionary data structure. So in this case, I have an array called spaceships, and the key in the array is the series name, and the lookup value is the name of the spaceship associated with that television series. So if I wanted to find, for example, the Starship Enterprise, and I know that it's from the Star Trek series, I would ask the array, hey, give me the value that you're storing that's associated with the Star Trek television series. And then to list all of the elements in an array, an associative array or an indexed array, we can use the for each statement. Now we've seen this in the last demonstration. We listed all of the elements of the integer array using a for each statement. So the for each statement says, hey, take everything that's in this array individually and call it name. And then in this example, just echo that name. So let's go look at some code. Okay, in this little snippet of code, I want to demonstrate again the indexed array. So we use the keyword array and we assign that to a variable called counter array. In that array definition, we've put 10 integer values. So this is an integer array, an indexed integer array that's being stored in the variable counter array. And then we simply use the for each loop to print each value that's being stored in the array. So we say for each value in counter array, call that value num, and then echo it out using that name num. So num becomes a representation of each of the elements in the array as the for each loop iterates over those elements. Notice also that I've scaffolded the code here with the debug equals 1. So that lets my debug conditional statement execute. And in this case, I am just dumping the contents of the array using the print_r function. And then I create an associative array. Now the associative array takes two values for each entry in the array. One is the key value. It is the value that we're going to use to look up the other value. The second value is the value that we want to look up. So in this case, we are using the key Star Trek to look up the value Enterprise. Notice the new operator that we're using. This operator is the equal sign greater than sign. What it tells PHP is to associate the value on the left with the value on the right. So now we can look it up like a dictionary. We look up the word, we find the definition. We look up the key, we find whatever value we're storing there. So in this associative array called spaceships, I can access any of the elements in the array just by using the key. So the next statement is looking for the spaceship associated with Star Trek. And then I can use a for each loop. And again, the for each loop for an associative array will work exactly like it does for an indexed array. It takes every element in the array and it says for each value, not the key, but for each value in the associative array, call it names. Inside of the for each loop, I just echo the name. The for each loop is managing going to each key, looking up the value associated with each key, assigning that value to the names variable, and then letting me do something with it. And again, in this case, all I'm doing is echoing. And then I have another debug command that's just dumping the contents of the associative array. So let's run this, and you'll see I get my counter values as expected from 0 to 9 in the for each loop on the indexed array. We've seen this before. Then the print_r statement gives us a nice printout of the array contents along with their index. The next line is the echo here of the associative array lookup for the key Star Trek. So Kirk was the captain of the Starship Enterprise. And then the for each statement for the elements within the spaceship associative array. We get the three elements looked up for us by the for each statement, assigned to the names variable, and then echoed. And then finally we get the dump statement, the print_r statement dump of the associative array. And notice that it's a nice, useful output. it gives us the key and the associated value with that key. The last thing I wanted to demonstrate is what I warned against earlier, is that in an indexed array, we cannot step outside of the bounds of the array. So our counter array has 10 integer values stored within it. So the index of the array is 0 to 9. And in this statement on line 22, I am accessing the counter array position 12, which does not exist. There is no position 12. So the memory space that is there wherever 12 would be does not belong to the counter array, so that when we try to access it, PHP is going to give us a pretty nasty error. So let me save this and then go back over here and reload our page, and you'll see the error is an undefined offset. Offset is just a fancy word for a memory location. And so here we see clearly that this array, counter array, does not own the memory space at position 12 in the memory. And so PHP just gives us a fatal error. Okay, so again, it's your turn. In this exercise, we'd like you to create a web page that's going to validate a username and password. So to do that, set two variables, username and password, to the values that are shown here. Then use an associative array that stores usernames and passwords and test against that associative array. So you'll have to loop through each value in the associative array, test to see if the password that's given is correct. Now, obviously, add more values for the associative array. I've given you 3 examples here. Add more. One of those must be S. Connor with the password fate that we make in order for you to find the value. It must obviously be in the array. And so if you find the password value associated with the username, then just print a statement, echo a statement that says welcome. If you can't find the username, or if the username's password is incorrect, then print try again. A simple function is fantastic. It can do all kinds of things for us. However, what it can do for our application is limited by its inability to interact with the data in our application. One way that we can allow a function to interact with the data within the application is to pass that data into the function when we call the function. In order to accomplish that, we need to tell the PHP preprocessor that this function is expecting this value. And we do that by including a variable name within the parentheses in the definition of the function. The example here shows a function being created. Keyword function, the name of the function is my function, and within the parentheses of that definition, I've declared a variable called myArg. That variable, myArg, will be accessible to the code within the function code block. If I wanted to pass multiple arguments, then I would just list them, separate them by commas. Then those arguments by those names are available within the my function code block. A call to a function that requires arguments obviously requires that the caller pass values into the function call. When those values are passed in, they are assigned in the same order that they appear within the parentheses. They are assigned to the variables that we defined in the function definition. So in this example, the string 1 will be assigned to arg1. The integer 2 will be assigned to arg2, and the string 3 will be assigned to arg3. Those names, those variable names, are how we, within our function code block, can access that data and act upon it. Now, just to be clear and technically correct, When we define a function and list variables that the function expects when it's called, those variables are referred to as parameters. When a call is made to a function and values are passed into that call, those are referred to as arguments. Over the years, these two terms have become somewhat synonymous, but to be technically correct, you should know the difference between the definition of a parameter and that of an argument. Now we have a function that's going to take values and act upon those values, and presumably the function is going to do something interesting with that data and return something to the caller so that we can continue to execute our code in the application. When we want a function to return some data to the caller, we use a new keyword. The new keyword is return. Return something. Return this to the caller. Now, the caller may choose to ignore the data that's being returned. If a function call is on the right side of an assignment operator, then whatever data is returned by that function will be assigned to the variable on the left side of the assignment operator. If you call a function and it is not to the right of an assignment operator, then that value that's returned is just dropped on the floor. It has no life outside of the function. So to get data back from a function, we as the caller must catch that data with an assignment operator. A function allows us to encapsulate a group of PHP statements, a collection of statements that generally do one thing, some specific task. The function may require some values in order to do that task, and when it's done the task, it may return some value to the caller. When we call a function, we cause it to be executed. When we include a function on our web page, it doesn't, unlike the rest of our PHP code, automatically execute when the page is loaded. The function is only executed when it is called by another piece of PHP code. The beauty of a function is that we can write a function that does something. Somebody else can use that function without really understanding how it is that the function does what it does. It just does it, and we call it, it gives us a value back, and we're happy without knowing the details of the implementation within the function. This level of abstraction is very useful for building libraries of functions that provide the ability to do very complex tasks without really understanding how those tasks are being accomplished. So to create a function, we have a new keyword called function. The function keyword is followed by the name of the function and an open and close parentheses. The block of code that defines the function is enclosed within braces. Everything within the braces that follow a function is that code block that belongs to the function that will be executed when the function is called. So someone calls a function, they're the caller. The function may return a value, and when the value is returned, it's returned to the caller. Unlike variables, function names are not case sensitive. So we don't have to worry about case with a function name. But when we do name a function, we should give it a name that reflects what it is that it's doing to make it more intuitive. So let's go look at some code. Here's our first function, a very simple function called hello function world. What this is demonstrating is how to create a function, how to declare it. We'll notice the function keyword. On line 10, the function keyword tells PHP that what we're defining is a function and its name is hello function world. Then notice that on line 10, the function must end in open and close parentheses. This is part of the function syntax, the rules for defining a function. We use the keyword function, we have a name for the function, and then we have the open and close parentheses. Then, to begin the block of code that belongs to the function, we use a brace, an opening brace. Everything inside of the opening brace until the closing brace is the code that will be executed when the function's called. And in this case, it's a very simple function that's just going to print out hello function world and then give us the current value of the internal variable. So we're creating a variable, very simple integer variable, and we're printing its value. The reason for doing this is to show that that value exists within the call to the function, that it has no lasting value outside of the call. As soon as the closing brace is executed by PHP, this internal variable is deleted. It no longer exists. And you'll also notice that I've scaffolded this code. This is a habit that, in my opinion, you should get into. When I execute this, this will tell me that the function's been called. I am inside the function and it's been called. That's a very useful way to trace the flow of execution of your PHP code. And anytime I want to turn that off, I just set debug to 0, and then this has no effect and will not be printed out. The if statement will fail, and that echo statement will not be printed out. So when I'm debugging, I can trace the flow of execution of the program by setting debug to 1 and then turn it off when I send the code to the testing department or to QA or into production. So then down here, I'm actually calling, on line 21, I'm calling the function hello function world. And again, I'm trying to emphasize here the fact that function names are case insensitive. The upper and lower case characters in a function name do not matter. This is a big difference from variable names where upper and lower case matter and variable names are case sensitive. But notice how we call the function. Within our code, we just give the name of the function and the parentheses, the open close parentheses. And this identifies for the PHP preprocessor, hey, this is a function call. Go execute the code within the function. Then I call it again on line 23, and then I call it again on line 25. I call it 3 times here to demonstrate the case insensitivity of function names. So let's run this. I'll reload the page, and we'll see that our first call, we get the echo from inside of the statement. Then we get our output from the function, which is hello function world, and this is the value of the internal variable. Well, the internal variable's value is 1. Then we call it again, and again we see that the code is flowing into the function with the call due to the scaffolding that's built into the code. And then again the third call. So there's nothing magic about functions. It's a new keyword, the function keyword, some name, and then the open and close parentheses, followed by the block of code that you want to be executed by that function. And that block of code is like all of the other blocks of code we've looked at for the if, the for each statement. Those blocks of code, including the function code block, is enclosed by opening and closing braces. So I've got a function that takes arguments. Some of those arguments are required for the function to do the task that it's designed to do. Maybe one or more of the values that the function expects could be default values, could be a value that the caller doesn't necessarily need to pass in, that we could use some default value for the calculation. To define a default value for an argument in a function call, we use an assignment operator to the right of the argument in the function definition. So in this example, I have arg1 and arg2, and arg3 equal to a default value. What that says is that when this function is called, the caller must provide at least two arguments, an argument for arg1 and an argument for arg2. They may or may not provide an argument for arg3, because arg3, if no argument is passed in, is going to get a default value string as its argument. So now that I've declared arguments within my function, what is their lifespan? What is their ability to interact with the rest of the application? The answer to that is simple. They have absolutely no ability. Arguments within and any variables that we create within the scope, within the block of code that defines the function, have absolutely no access to any code outside of the function, nor does any code outside of the function have access to those values within the function code block. So it's kind of a wall that prevents access in or out of the function to the values that exist within that function. We call this local scope, local and independent scope within the function for variables that are created or passed into the function. Now we can override that with another new keyword called static. The static keyword tells the PHP preprocessor, hey, this is a special variable. I want this variable to have a lifespan between the function calls. So if caller 1 calls the function and sets a static variable to the value 1, then the next caller, caller 2, will see the value 1 for that static variable. Now caller 2 sets the value to 2. Caller 3 sees the value of 2 for that static variable. So the static variable overrides this local and independent scope of function variables by allowing the value to live beyond the call of the function. Now, why are functions so important? Functions allow us to encapsulate very complex code and allow others to use that code without really understanding the implementation details, just knowing that if I pass A and B in, I'm going to get C out, and I'm happy not knowing the details. PHP provides us thousands of functions that we don't need to understand. We don't need to know how the function does what it does. We just need to know what the function does and what arguments the function expects and what value the function may return to us. That's all we need to be able to use the function. How do I call the function, and what do I expect back from the function? There are functions to do all kinds of interesting things that are built into PHP, and they're generally organized by category. And I've listed some of them here, but these are only the built-in functions. If you do an internet search, you'll see that there are thousands upon thousands of PHP libraries that provide functionality that is amazingly useful in building applications, none of which require us to understand the implementation of the function. Only how do we call the function and what do we expect from the function. So let's go look at some of this code. In this code snippet, I've declared a function called getSpaceship, and that function is going to take an argument, a parameter. That argument is name of show. And what I've done here is I've said, hey, if the caller decides not to pass a value when they make a call to this function, that's okay. Use this default value. In this case, the string Firefly. Defining the function on line 11 is the keyword function the name that you want to give the function, and again, try to use a name that is descriptive of the purpose of the function, then the parentheses, and in this case, within the parentheses, the parameter that the function expects. Inside the function, I've scaffolded the code so that I can trace the execution of the application when this function is called. And not only that I know when it's called, but notice that I'm also outputting the value of the argument that's passed into the function. This is amazingly helpful during debugging. Again, I recommend that you get in the habit of scaffolding your code. Then inside the function, I'm creating a static associative array named spaceships. Now, associative arrays shouldn't be scary, so the only new thing here is the static keyword. And the static keyword tells the PHP preprocessor that this variable spaceships is going to have a life that spans all of the calls to this function, so that it's going to live, its scope is going to be beyond the single call of the function. And then in line 18, I actually look up the value associated with the key that's passed in as an argument and return that to the user. On line 21 is a demonstration of a call to that function. We've combined the call to the function within the echo statement and concatenating it with a string. And so let's run this. We get the output that we expected. In our scaffolding trace, we get the message that we've entered the function and we get the value of the argument that was passed in. We look up in the static array the value associated with the key that's passed in this case Star Trek, and we return that value to the caller. The call is made on line 21, so the value that's returned from the getSpaceship function is concatenated with the string as part of the echo output. And that's what we see in the second line of the output. Now, somewhat more interesting is using some of the built-in functions that are provided by PHP. For example, some of the network functions. We will not be covering in detail all of the thousands of available built-in functions provided by PHP, but here are a few that are interesting. I have a URL, cnn.com, and I want to know what the IP address is of that URL. There's a function for that, getHostByName. And when I call that function, getHostByName, it returns to me the IP address of that host. Do I care how it goes about doing this? I don't. All I know is that I can look up this function and it tells me that it requires the host name as an argument, and it will return to me the IP address of that host name. I'm not interested in how it does that work, how it implemented the code, just that I give it a host name and it returns to me an IP address. Likewise, the next call on line 17, we can pass an IP address and request as the return from this function call, getHostByAddress, I pass the IP address, and in return, I get the host name. Do I know how this function accomplishes that task? No, I do not. And I don't care to know. All I care about is that I can call this function simply by passing an IP address, a string containing an IP address, or the IP address embedded within the call, and get back the host name. How about more network detail? How about I'd like to get the DNS record associated with some host name? Well, there's a function for that as well, DNS get record. This goes to one of the domain name servers, the default which your internet connection is configured to use, and asks that server for this host name, give me the DNS record. And then some calendar functions. On line 32, there's a calendar function that takes a Julian date and returns a Julian day. A Julian day, a JD, is a numeric value that's associated with a date. Taking that Julian day, that JD value, and on line 33 we can call a function JD day of week, and we can ask this function, hey, what day of the week was this specific day? Do I know how any of this is calculated? Absolutely not. And I don't need to know. I look up these functions in the PHP reference, and I see that Julian to JD takes 3 arguments: the day, the month, and the year, separated by commas. That's what I've passed into this function. In return, this function gives me a JD value. Now, I need that value because I really wanted to know what day of the week my birthday was. So I say JD, day of week, and I pass this value that was calculated. So let's run this and see the output. And we'll see that the IP address of this host name is given to us. Using this IP address, we can do the opposite and look up the host name. Then we can ask for the DNS record, and we get a dump as an associative array from the DNS server of the information in the DNS record. And then our calendar functions took the date 1/1/1995, calculated the Julian day for that, then calculated the day of the week that that date fell on. So pretty exciting. So the world is opening up in that there are thousands upon thousands upon thousands of functions that we can use that do interesting things that we don't have to have any knowledge of how they do what they do. The only thing we need is what arguments do they require and what the value is that they're passing back that we can catch and use in our application. Now it's your turn. In this exercise, we'd like you to create a function called validate user. That function is going to take 2 parameters, and it should look like this. Validate user takes a username and takes a password as parameters to the function. Then use an associative array, a static associative array within the function definition to store a set of usernames and passwords. I've given you again here a few samples of usernames and passwords that you could use. Going to need obviously to add to it. Then create a web page that includes this function that you've written and the PHP code to validate a username and password. Then we'd like you to test the password against the username, find the user, and then test the password. And if the password's correct, return true from the function. Otherwise, return false. On your web page where you're calling the function, if the function returns true, then echo welcome. Otherwise, echo please try again. Clearly, functions are powerful tools for building non-trivial, interesting applications in PHP. Functions give us the ability to reuse our code and to even share it with other developers. But rather than copy and paste the code into the different web pages that we want to use the function, we need a way that's more robust and maintainable that allows us to include that function code everywhere we might need it in an application. PHP provides 4 mechanisms for us to include code that exists in another file. The idea is that we create our function or functions in a file. Then when we want to use those functions in another part of the application, rather than copy and paste the function code, we just include the file where those functions are defined, and PHP does the work of including that code in the application where we need it. One of the mechanisms for doing that is the new keyword include. we say include and give it a file name, in quotes. PHP does an automatic copy and paste. It takes the contents of that file that's named in the include statement and puts it into our application. Now, we may need the file only once within a web page. Rather than risk copying and pasting the code from our function file in multiple places on the same web page, we could use include once, which is identical to include, with the exception that PHP, in the case of include once, PHP ensures that the file has not already been included somewhere else within the scope of the code block. The require command is exactly like the include command, except that if the file doesn't exist, require will throw a fatal error and terminate the application. Require once, again, exactly like require, except that PHP keeps track of whether or not the file has already been included. And require once, both will throw a fatal error and terminate the application if the file is not where specified, or if the file does not exist as defined in the require and require once statements. So let's go look at some code. We've taken our function from the last demonstration, the getSpaceship function, and we've put it in a separate file. We call the file spaceshipfunction.php. The function does what it was doing in the last demonstration. It looks up, based on the argument passed to it, it looks up a value in an associative array and returns that to the user. So let's go see how we use this in our web page. In our PHP code, we say include and the name of the file. In this case, include spaceshipfunction.php. When the PHP preprocessor encounters this line of code, include spaceshipfunction.php, it does a simple copy and paste. It takes all of the code within spaceship function PHP file and pastes it in this file at the place where the include was encountered. So let's run this. We get the answer that we expected from the function. What happens if we include a file more than once? Well, PHP won't like it, and we'll get an error that looks like this. And it's a fatal error that will terminate the execution of the application. So it is much safer to use the include once command, because PHP will keep track of what files have been included and prevent the multiple inclusion of files. So we see now in this case, we've called the function, we've gotten the response we expected, and even though we have 2 attempts to, in fact 3 attempts, to include this file, to copy the contents of this file into our code, it only happened once. Now, what happens if we don't have a file and we try to include a file that doesn't exist? Well, that's a nasty error too, but with the include statement, all we get is a warning. We get a warning that says, hey, the PHP processor can't find this file, but it's just a warning, as opposed to the require statement that generates a fatal error and terminates the application. Now, the implications of this are, if you have critical code that enforces security or does some kind of authentication or validation of user input, and you use the include and that file is not there, then the include statement will not terminate the application, will not throw a fatal error. And that may open your application to serious security issues, whereas the require will throw a fatal error and terminate the application. Now, this is very useful for functions, having the include and the require statements that allow us to essentially automatically copy and paste code. But there's another reason to use the include and require statements. So imagine that we have a piece of HTML code that we want to be able to use on every page of our website. So I create an external HTML file, and within that, put whatever HTML statements that I want to include on every page of my website. Then within the pages on my website, I just include that external HTML.php file, and that HTML, in this case, the level 1 header, will be printed on every web page where this code snippet is included. So let's see what this looks like. Let me reload the page, and there we go. So now Acme Widget just got bought out, and the new company says, hey, we need to update the name, and we need to do that right away on all of the pages on the website. So rather than going to visit all of those pages, we go to one place and say, welcome to the former Acme Widget Company, and I can go back here, and with a single change in a single file, I could have affected every page on the website. This is the true power of the ability to include external PHP content into our files. An application should be robust, reactive, and interactive for the user. This includes in the face of runtime errors. These types of errors are unexpected. The application's gone through the testing process and has been launched into production and is assumed to be sound. However, a runtime error, some exceptional circumstance has occurred that causes the application to crash. We need to manage this type of error, this type of exceptional circumstance. In PHP, we refer to these types of runtime errors as exceptions, and PHP allows us to manage these exceptional circumstances by changing the flow of execution of our application in response to these errors. The mechanism for managing these exceptions uses two new keywords, try and catch. Try and catch are part of the exception handling mechanism in PHP. Try encapsulates a block of code, protecting that block of code. Anything within the try block is protected from an exceptional runtime error. If an exceptional runtime error occurs within the code in a try block, the flow of execution is transferred to one of the catch blocks that are associated with that try block. A catch block can be written to respond to any type of runtime error, and the response can be any legitimate PHP code, so that we can be reactive to runtime errors in our code that protect the state of the application and allow us to recover from these errors so as not to affect the user experience. In general, an uncaught exception, an uncaught runtime error, will result in a fatal error and the application will terminate. So let's go look at an example. In this snippet of code, we're demonstrating the exception handling mechanism in PHP that allows us to control the flow of execution of code in the face of a runtime error, an exception. In this first execution, we will get the output we expect because there is no error. We executed the code on line 13 within the try block, and there was no error, so the flow of execution was normal. Well, now let's introduce an error. So we introduce an error using this new keyword, throw, and we're going to throw an exception type. So the syntax we'll discuss in detail later, but the syntax is to throw a new exception type. Now, exception is a class, and so we need to create an object of that class, and we use the new keyword. That's All of that is going to be discussed in the very near future in this course, so please don't concern yourself with that at this time. Just know that we are going to cause a runtime error to occur so that we can demonstrate how the flow of execution in the program changes in the face of that error. So I've made my change, I save, and I execute, and we can see now that at the point that the exception, the runtime error, occurred on line 12, line 13 never got executed. Within this try block, all of that code is protected from runtime errors. When a runtime error is encountered, the flow of execution transfers to line 17 and the catch block to manage that runtime error. So we threw an exception. The exception was caught in the catch block, and that catch block output two echo statements that redirected, in this case, the user to a different part of the website. Notice the syntax. We have our new keyword try, and we have the opening brace of the code block. The closing brace of the try code block immediately followed by the catch keyword and the type of exception in parentheses that the catch is handling. We'll see an example of this in a moment where we can have multiple catch statements dealing with multiple types of runtime errors. And then within the code block of the catch statement, we have our recovery code. We have the reaction to the error that we want the application to take. Once the catch executes, if we don't redirect to some other part of the code by calling a function or some other transfer of execution, then the flow of execution will continue with the code that follows the closing brace of the catch statement. So the exception handling mechanism can manage multiple different types of exceptional circumstances that might happen in our application. And because we can't plan for these circumstances, because again, they are exceptional, they are unexpected runtime errors, we have to design an error handling mechanism that is as robust as possible in dealing with any possible error that could occur during runtime to protect our application and the user experience. To do that with the try-catch mechanism, we just include more catch blocks. We can include a catch block for each type of exceptional circumstance that may occur, and PHP will manage which catch block to call based on the type of exception that occurs during runtime. So let's go look at some code. So in this code snippet, we're going to demonstrate how we might respond to multiple types of exceptions that could occur in our application. In order to respond to multiple potential runtime errors, we need to define multiple catch blocks. And in doing so, we need to define those catch blocks from the most specific type of error that might occur to the most general type of error, because the PHP preprocessor will check the type of error that occurs against the type listed in the catch blocks in the order that the catch blocks are listed following the try block. So most specific down to the general type of errors, so that we can trap those specific types of errors, those more specific type of errors during runtime. So in this case, we haven't changed anything from the previous demonstration, except that we've added a new catch block. And this is a specific catch block so that it is catching a logic exception. which is a more specific type of exception than the generic exception type. So if we had an exception of type logic exception, then this code block should execute. If we have a more generic exception type or any other exception type that does not match the logic exception, then this catch block that takes an exception type will execute. So again, this should respond exactly as it did in the previous demonstration, and certainly it does. It executes the code in the catch block starting at line 24. So now let's generate a more specific runtime error, a logic exception. So we're going to throw this logic exception and see where the flow of execution is going to be transferred. What we expect is that because this is a type logic exception, that the PHP preprocessor will match the catch that's defined for the logic exception type and execute the code in the catch block beginning at line 18. So let's save this, and there we go. So now we have responded to this very specific runtime error type by executing a different block of reactive code, of error management code, than we did when we threw the more general exception type. So the point here is that we want to create our catch blocks so that the most specific exception types are listed first, because the PHP preprocessor will begin the matching process from the first catch block after the closing brace of the try block until it finds a match. The advantage of using a server-side programming language like PHP for developing internet-based applications is that PHP has complete access to the resources on the server. Those resources include the file system. And not only can we read and write files easily with PHP, we can do other manipulations of the file. We're going to focus on reading and writing the files on the server using PHP. Well, before we can read a file, we need to create what's referred to as a handle to the file. To do that, we call the fopen function, and we pass it the fully qualified path to the file and identify to the function fopen what mode we want to use for reading the file. We can use R for just reading from the beginning of the file sequentially, or we can use R+, which tells the fopen function to open the file for reading and writing. Now, how much data is in the file? We can get that information by using the file size function. This function returns the number of bytes in the file. Now, if we want to read the entire file, or if we want to read just a limited number of bytes from the file, we can use fread. The fread function takes the file handle and some number of bytes and returns the contents of the file to us. When we're done with a file, the best practice is to call fclose on the file handle to release those resources. Now, this isn't absolutely required because PHP will close all open files when the application terminates. However, it is best practice. Now, how else can we read data from a file? There's a function fgets that will read a single line of data from a file. And then even further, we can use fgets to read only part of a single line from the file by specifying in the function call the number of bytes to read. Now, depending on the content of the data, we could use the function fgetss will strip the HTML and PHP tags from the input data as it's read. Another very useful function, fgetcsv, will read a comma-separated file directly into an array for us. Now, if we're reading sequentially from a file, we need to know where the file ends to be able to control the iterations through the file. We can do that with the FEOF function. This is the end of file function. The FEOF function will return true when we reach the end of the file. So we can use this function as a loop control variable to continue reading a file until we get to the end of the file. And if we want to move around within the data in the file, we can use fseek. Fseek changes our position within the file. Now, writing to a file is no more difficult than reading. Again, we need to create a handle to the file, and we do this by passing a fully qualified file path and then specifying the mode with which to open that file. And we have four choices for writing to a file. We have W, W+, A, and A+. The difference being that the W and W+ overwrites any existing file contents, while the A and A+ append to the end of an existing file. When we want to write to the file, we call fwrite. We pass the handle and we pass the data that we want to write to the file. And again, not required. However, a good practice is to always call fclose when we're done with a file. So let's go look at some code. Our first code snippet is going to demonstrate how to read data from a file. The first step in doing this on line 13 is to define the fully qualified path to the file we want to read. I assign this fully qualified path to the variable file name. Notice that I'm using single quotes. I do this because I do not want to have to escape the special characters that are embedded within the string. And the single quotes, recall, pass the string as is without interpretation by the PHP preprocessor. The next step on line 14 is to call the fopen function, passing the fully qualified path to the file and the mode that we want to use to open the file. In this case, I want to just read the file, so I pass an R for the mode. Fopen will return a file handle. I store that file handle in the variable file. On line 15, I test the variable file to ensure that a valid file handle was returned by the fopen function call. If fopen cannot open the file and create a file handle, it returns false. So I can test for that error and deal with it here inside of the if block. On line 20, I call file size, passing again the fully qualified path to the file, and file size returns the number of bytes of data in the file, which I assign to a variable file size. Then I make the call to fread, and fread will read from a file the number of bytes specified. In this case, I say, from this file, read the entire contents. File size represents the total number of bytes in the file, and I want to read them all. I assign the return from fread, which is the data from the file, into a variable file text. And then I call fclose on the file handle, which releases the resources back to the system. On line 25 and 26, I echo the values that I've read from the file. So let's run this. I will reload the page, and we see we have a file with 310 bytes of data and the values as listed here. Now notice that the values are comma separated. Title of the movie, comma, director. This is important for the next code snippet we're going to look at, which uses the fgetCSV function. On line 13, we're doing the same thing, defining the fully qualified path of the file and assigning that to the file name variable. On line 14, we're opening the file passing the fully qualified file name, and setting the mode to read. The R sets the mode to read. Then we test the file handle to ensure that the file was opened successfully. Then on line 21, I set up a loop, a while loop, to iterate over the contents of the file. Now I do that using the end of file function, FEOF. And FEOF requires a file handle. So I pass our file variable, which contains the file handle, to the FEOF function. And I set my while condition to when not end of file. When FEOF encounters the end of the file, it will return true. Otherwise, it returns false. So I set my condition to not, using the bang operator, not end of file. So as long as FEOF returns false, then the while loop will continue to iterate over the contents of the file. Within the while code block, I call on line 23 fgetCSV, passing the file handle as an argument. fgetCSV returns one line from the file and parses that line using the comma as a delimiter, and then I assign that value to an array named contents. I set the index of the array using the I variable, and I'm iterating here over a file, so I need to increment the index of the array, and I'm using the shortcut here, the ++ sign. So the array index will be automatically incremented each time through this loop. When we reach the end of the file, FEOF will return true and the loop will terminate. Then on line 25, I print the contents of the array. So let's run this one. And we get our array, and it's an associative array. We get the values of the data contained within the file that we read. So a very useful function, fgetCSV, for parsing comma-separated files. So our next snippet writes to a file. The process is very similar to reading from a file. On line 13, we define the fully qualified path to the file. On line 14, we open the file calling the fopen function. Notice that the mode that I'm using on line 14 is A for opening the file. The A is the augment or amend mode to open a file, as opposed to the W mode, which truncates a file, overwrites the contents of the file. The A mode will add to the end of the file anything that we write to it. Again, I test the return from fopen to ensure that a valid file handle was returned. Then I call on line 20 fwrite. I pass the file handle and the value that I want to write to the file. Now, because we open the file using mode A, this value will be appended to the end of the file. Then I call fclose to release the resources associated with the file handle. Then on line 26, to confirm that the data was written to the file, I again read from the file. This is the same from line 26 to line 39. This is the same code that we just looked at in the previous code snippet. So when we run this, we see that the string, I love all of these movies, was appended to the end of the file. In addition to reading data files, another very common task when writing PHP applications is to read application configuration files. These are external files that store the application configuration values in a specific format. There are two generally used formats for external configuration files. One is to list the configuration settings in key value pairs, and another is to write the configuration file in XML format. In either case, PHP provides built-in functions for reading those configuration files. For key value pairs, PHP provides the parse any file, parse underscore ini underscore file function. When we use this function and provide it with a configuration file name, the function returns an associative array of key value pairs from the configuration file. Now, it does expect a specific format for those configuration values, an example of which I've included. XML is a preferred format because of its popularity as a self-describing data file. PHP provides a simple XML load file function that returns a collection of objects that contain the XML data. In our case, the XML configuration data. Let's go look at some code. So our next code snippet is something that's actually very useful in the initialization of an application. This is such a common task that PHP provides us a function that implements a lot of the plumbing for us in doing this work. So we're going to parse, read in and parse this file. This is our configuration file for our application. It identifies our database login information. It identifies what level of debugging that I want for this execution of the application, and it identifies the directory, which is the root of the application. So this is an application configuration file, and we need to read this data in to our application. Now again, application configuration files are preferred over hard coding these values into our application. So on line 15, I call the function parse underscore any underscore file. Again, this is a built-in PHP function that will read and parse a configuration file. Well, notice though that the format of the configuration file is fixed, and this function expects a specific format for the configuration file. So we call the parse any file function passing our configuration file on line 15, and that returns to us an associative array that we can then read. And on line 16, I read that associative array, and I'm looking for the debug section of the configuration file and the value of debug on within that debug section. So again, from our configuration file, I have a section debug, and within that I have a value for a configuration for debug on, and that's what I'm looking for here in my call to the associative array that was returned by the parse any file. And then I print that, and then I'll print on line 29, I print the entire associative array. And a new function for us on line 22, a new function unset. This releases the variables that were previously defined. I do this because I want to reuse those variables, and I'm going to reuse them here to call another function that is useful for reading an application configuration file. Except this application configuration file is written in XML. Same data in XML format. So I'm going to read this XML with one function call to the PHP built-in function simple XML underscore load underscore file. And the argument for this function is the name of the XML file. The return values from this function are accessed as shown on line 30. We use the arrow from the variable to the node to the value that we're interested in. Then on line 31, I print this value, and on line 32, I ask for a different value, in this case, the value of root in the XML file. And then I'm going to print the entire contents of the XML file as returned to this code snippet by the call to simple XML load file. Let's run this, and Here's the output. In my first call, using the parse any file function, I've read the values and I get a value of 1 for the debug on configuration setting as read from the any file. Then I dump the entire contents of the array representing the data that was read from that file. Next, I read from the XML file. In the XML file, you'll recall I have reset the value of debug on in order to contrast the read from the any file, where the value was set to 1. In the XML file, I set the value to 0 for the debug on configuration setting. When I read this value using simple XML load file, I get the value of 0 because it's being read from the XML file. And then again, I read the root value from the directory node in the XML file. Then I dump the entire contents of the config variable. Now, I don't want to get into a discussion of an object yet. We will be discussing objects and classes and object-oriented programming in a coming video. But note that the return from the simple XML load file function is an object that is holding the XML data that was read from that file. So again, it's your turn. In this exercise, we'd like you to enhance the validate user function from the previous exercise to read the contents of the file usercreds.txt. Read this data into a static associative array that will store usernames and passwords for the application. The validate user function should be in an external PHP file to be included into the application file. Then create a web page to validate a username and password by calling the function. Again, use the username sconnor and the password fate that we make as arguments to the function. Find the password associated with the username, test the password, and if it's correct, return true from your function, false otherwise. On the application page, if the function returns true, print welcome. Otherwise, print please try again. One of the great strengths of PHP is its ability to process our application's form data on the server side. In fact, we could go a step further and generate the forms using PHP code. We've generated HTML from within our PHP code, so we know how to do that. Here's an example of a simple login form. It has two fields, username and password. It's beyond the scope of this course to discuss the HTML form tag. However, this is a simple example with two fields, username and password. The action associated with this form is to call the process login PHP file and pass the data from the form to that file using the post method. So a user's browser, the client, communicates with our server with either the get or the post method. The same data is transmitted with either get or post. However, the mechanism for the transmission is significantly different. With the get method, the form data is passed in the query string and is therefore visible. So we should never use it for sensitive data like usernames and passwords. In contrast, the post method passes the data back to the server in the HTTP body so that it is not visible. Another big difference is that the get method may actually be limited in the amount of data that can be sent back, whereas the post method has no limit. In both cases, the get and the post store the form data in key value pairs, giving us access to that data on the PHP side using the associative array syntax that we're comfortable with. To access the data, PHP provides us Superglobals. This is a new concept. There's a set of superglobals that are populated automatically for us by the PHP preprocessor. Two of those are the get and the post superglobal. When the data is passed back to our server using either get or post, we can access that data using the get or post superglobal and the associative array syntax that we're already comfortable with. So let's go look at some code. Here's our login form. Simple form, username and password fields, and a submit button. Here's the code that generates that login form. The HTML code is, again, beyond the scope of this course. However, the action associated with the form is to call the processlogin.php file and pass the data via the post method. So the data is going to be encapsulated within the HTTP message body and passed to the processlogin.php file. We include the processlogin.php file with a require once command. In processlogin.php, the first thing we do is make sure that the username and password fields that are in the associative array in the post superglobal are not empty. Then we drop into the if block and we trim the values of username and password. The trim function deletes extra white space on each end of a string. So now we have a clean username and password, and we call the validate user function, passing those values, username and password, to that function. We've included the function using a require once command. In the validate user function, the first thing we do is read the contents of a text file named usercreds.txt. This file contains the username and passwords, comma delimited, for our application. We read the contents of that file into the creds variable. Then we use a function called explode that uses the comma as the delimiter to load an array with all of the values in the creds string. We assign that array to the variable data. On line 19, we test the value of the elements in the data array against the username and password that was passed in to the validate user function. If both the username and password match those that we read from the user creds text file, using the header function, we redirect the user to a login success page. Otherwise, we echo an invalid login attempt message. So let's see how this works. And there we go. We are into the login success page. Had we failed the login, we would have gotten our invalid login attempt message. So a pretty straightforward way of processing a login form, or in fact any form, using PHP and the post method. Superglobals are built-in variables that are populated for us by the PHP preprocessor. These superglobals can be accessed from anywhere within our PHP application. We've seen two of these superglobals, the get and the post superglobals, that allow us to pass information from a form on the user's browser back to our server for processing. Here are a few other superglobals that allow us to access information about our server and even allow us to store bits of information on the user's computer in the form of a cookie. Now, there are 9 superglobals provided by PHP. However, there are known security vulnerabilities associated with the use of superglobals, and their use is no longer recommended because of those vulnerabilities. We'll leave it to you to research the superglobal vulnerabilities and make the determination on whether or not to use them yourself. Cookies are small bits of information that we can store on the user's computer on the client side. Common use of a cookie is to store a username and password, or the user's preferences on our website, or the date of the last visit on our website by that user, shopping cart contents, and other small bits of information that we can use to initialize the application when the user next visits. To write a cookie, we use the PHP function setCookie, which takes 3 arguments. the name of the value that we want to store, the value we want to store, and an expiration date of when that cookie will no longer be valid. To retrieve the data stored in a cookie, we use the cookie superglobal with the name of the value that we want to retrieve. A few gotchas associated with cookies is that we can't assume that the cookie exists, because a user may have deleted the cookie. The browser may be set not to accept cookies. And it's important to note that cookies are not shared between browsers. Now, we'll discuss the session superglobal. However, there are known security vulnerabilities that have been published associated with the session superglobal. The session superglobal is a variable that's used to track information related to a user's visit. The session superglobal stores temporary data. When the user leaves the site, the data is deleted. The basic mechanics for managing a session are: 1, to start the session. Once the session is started, we can store values associated with that session. And at any time, we can destroy the session with the session destroy function. To store values associated with a session, we use the session superglobal using the value name as the key. Then to retrieve that session data, again, we use the session superglobal and the value name as the key, which will return the value of that session variable. In this exercise, we'd like you to create a login form. A login form with 2 fields, one for username and password. When the user submits the form, transfer processing to a PHP file. Ensure that the user has provided the requested information, and if they haven't, then provide an error message. You could redirect them to an error page. If the required information is provided, then call your validate user function, passing the values that were provided by the user. Now modify your validate user function so that it reads the username and passwords from the usercreds.txt file. Then test the value that's passed into your validate user function against the values in the usercreds file to verify the user's username and password. If the values are not correct, then provide an error message or redirect to an error page. If the values are correct, then redirect the user to the loginsuccess.php page. During the execution of our application, PHP allows us to store information regarding our interaction with the user in variables. However, the information stored in those variables goes away when the application terminates. We need to find a long-term mechanism to store the information about our user interaction. Now, we could use file storage as a solution. However, file storage is slow, and unless you're very disciplined as a developer, it is unorganized. Enter the database. The database is specifically designed to provide organized, high-speed data storage and retrieval. In the LAMP stack, we typically work with MySQL. MariaDB is a branch off the development tree for MySQL and is binary compatible with MySQL. Then there's SQL Server and DB2, Postgres. There's a wide variety of different database systems that are available for our use. But again, typically in the LAMP stack, we'll be talking about either MySQL, or MariaDB. In any case, whatever database system you're using, PHP provides an easy-to-use abstraction layer, an interface to those databases, so that we can focus on the functionality of our application rather than on the details of communicating with the database. So what is a database? Well, a database is just a container of structured data that's organized for fast retrieval. That's the key. A database is all about giving us the data that we ask for as quickly as possible. A database is organized in tables. The tables are organized in columns. The columns organize the individual data fields, and a row within a table represents an instance of related data. As an example, we have a movies table that organizes information about movies. An instance of a movie is a row in the table. The table is defined as having an ID field, a movie title field, an actor's field, a director's field, a year field, and a rating field. When we ask the database to give us an instance, to give us a row from this table, what we receive in return is the data associated with one movie. So how do I ask the database for this data? There are 4 basic commands for interacting with any relational database: select, update, insert, and delete. If you know these 4 commands, you can generally successfully interact with a database. Select retrieves data from a table and has a syntax for doing that. Update changes data that exists in a table. Insert inserts a new set of values in the table. And delete removes some data from the table. But before we can send commands to the database, we have to somehow connect and authenticate ourselves with the database. So the first step is that the application must have a user account on the database so that it can establish that connection. A user account is simply just a username and a password on the database server itself. Once we have that and we know the server that we want to connect to, creating the connection is as simple as executing a function call. Much like reading or writing to a file, when we call the connection function for whichever database system we're connecting to, we're returned a connection object, a handle to that connection that we need to save in a variable so that we can use it when sending commands to the database system. Once the connection is established, we can send SQL commands using that database connection handle. And again, as developers, we should maintain our focus on the functionality of the application rather than on the details of the interaction with the database. In maintaining our focus on the application functionality, we can use any one of the many PHP libraries that support database interaction. These libraries provide a layer of abstraction so that we can focus on developing functionality for the application rather than on the detailed plumbing required to communicate with the database. In this application, we're going to connect to both a SQL server and a MySQL database server. The purpose of connecting to both is to demonstrate how similar the interface is to both database systems. So first, let's look at how we connect to the SQL Server database. I've put the connection code in a separate file. The first thing we do is define our environment. So we are going to connect to, in this case, a server that is local to my virtual machine, my username and password, and the database that I'm going to connect to. I put those values into local variables from which I then create an associative array, which I assign to the connection info variable. Again, I create an associative array using the connection information, assign that to a variable named connection info. Then I call SQL Server Connect, SQL SRV underscore connect, passing it 2 arguments. The first, the name of the server, and the second, the connection information for the server. The return from this function is a handle to the database server, and it is this handle that's going to allow me to interface with the database, that is, to send SQL commands to the database. If for some reason there's a failure in creating the handle, SQL Server Connect will return false. So I test for that on line 11. And if I've had an issue creating the connection to the database, I throw an exception and catch it in the catch block on line 16. Similarly, to to connect to the MySQL database, I create local variables to store the values of the connection information. So the name of the host, the name of the user, the password, and the name of the database to which I want to connect. Now again, my environment is different than yours. I run SQL Server and MySQL local on this virtual machine. It is likely that your database system will be in a hosted environment. Therefore, to connect to your database, you will use a different value for the DB host. And to find that value, you should check with your hosting provider. So then to connect to the database, I call MySQL I_connect, and I pass it the connection information. In this case, I pass it 4 variables: the location of the server, the username, the password, and which database on the server that I wish to connect to. And again, MySQL I_connect will either return the handle, the connection to the database, or it will return false. So on line 10, I test the return value, and if the MySQL handle variable is false, then I handle that error in the if block code, throw an exception, which I handle on line 16. With the code in both of these files creating the connection to the database for me, I can now go to my application code and simply require the inclusion of those files into my application file. So I use a require once and bring both of those files into my application. So the first thing we're going to do is define the SQL statements that we want to use to retrieve and to insert data into these databases. So I define a select statement. Notice the keyword select, the star from movies. The star means give me everything that's in the table. So select everything from movies. That's the SQL statement that we're storing in the variable SQL select. Now for the insert statement, because there is a slight difference in the syntax of the insert statements between SQL Server and MySQL, I've created 2 variables here, one for each of the database systems. For the SQL Server, my insert statement is insert into this database, this table. Movies is the database, movies is the table. These are the columns into which I want to insert, and the values that I want to insert into those columns are listed following the values keyword. So to insert into a database, we use the keyword insert into some database, some table. The columns that we want to insert into, the keyword values, followed by the list of values that we want to insert within a set of parentheses. In the MySQL insert statement, the only difference is in the addressing of the database and the table. Notice that there is only one period, one dot between the database name movies and the table name movies. So we insert into the database movies, into the table movies, for these columns, keyword values, and then the values that we want to insert into those columns in parentheses following the keyword values. Then a echo statement to delineate which data we're going to be looking at. Then I send the query to the SQL Server database system. And to do that, I call this function SQL Server _ query. SQL SRV _ query. What that function requires is 2 arguments: the handle to the connection and the SQL statement that we want to execute against the server. This function will return the results of the execution of that query, and we assign those results to a variable named results. To expose you to what you might see in some PHP code, I wanted to show the or die clause. This is the old form of error handling. If this function fails for some reason, if this function call fails for some reason, then this instructs the PHP preprocessor to report the errors. So this was pre-try-catch exception handling. And the only reason I've left it here is to expose you to it so that if you see this in older code, you'll know what it is. So now we have the results in our results variable, and we want to iterate over those results and print out the data that we've received from the database system. We use a while loop, and we ask the while loop to iterate while there are results being returned by the SQL Server _fetch_array function. What this function does is it takes the contents of the results variable that's holding the data that we received from the database system, turns that into an associative array using the column names as a key and the values returned. We can iterate through that set of results and print those values. Now we want to insert a value. And again, the insert statement we defined up here. Now we're going to execute it. Again, we use the same command, SQL Server _query. We pass it a handle to the SQL Server connection, and we pass it the insert statement. Now the result here is going to be the number of rows that were affected by the insertion. What we're interested in is verifying that the data that we asked to be inserted was actually inserted. So we're going to verify that. We're going to simply rerun our select statement. On line 44, this line is just setting up our SQL select statement, and we're repeating our while loop to print the results from the select statement, which should include a new row of data, that new row of data that we just inserted here on line 40. Then I do exactly the same thing with the MySQL database. Once I've gotten the connection to it, I call the MySQL I _query. Very similar to the SQL Server query, MySQL I query takes the handle to the MySQL connection and the select statement. Now in this case, the select statement is universal, so we're going to use the same select statement. In this result, we're looking at results from the MySQL database server, not the SQL Server database server. So when we iterate through the results from this query, we're iterating the same way. The results contain all of the data from the select statement. The MySQL I fetch array creates an associative array using the column names as the keys, which we can iterate through in the while loop, and we do that. Then we're going to run the insert command on the MySQL database. And again, MySQL I _query, I pass the MySQL connection handle and the insert statement. What's returned from this call is the number of rows that are affected. But again, we're not that interested in the number of rows that were affected. What we really want to see is the validation of the insertion. So we're going to rerun the select statement. So we're calling MySQL I query, and this time we're passing the select statement with the MySQL connection handle, and we're going to iterate over those results again. So remember that the MySQL I fetch array, just like the SQL Server fetch array, creates an associative array using the column names as the keys, which we can use to iterate over the results. And I've got all of this wrapped in a try block, and my catch for any exception that occurs within this block is defined on 104. So let's run this and see what we get. Okay, so we've got our SQL Server data. This was the data that was in the server when we did the select before the insert statement. Now we do the insert, and now we're going to print the data after the insert statement. And the data that we've inserted is the Star Trek Wrath of Khan movie information. On the MySQL database side, we selected and printed the values that existed in the table prior to our insert. We performed the insert. After the insert, we have a new record, Star Trek II, The Wrath of Khan movie information. In this demonstration, we've successfully selected from and inserted to both the SQL Server database and the MySQL database. And we've done that in the same application using the connections that we created for those databases. Object-oriented development can be a challenge to anyone new to the PHP programming language. It's a new way of thinking about how to write software. It's very powerful in that it allows us to encapsulate, to enclose the data and the behavior that acts on that data into a software construct that we can use throughout our application and in fact share it with other developers so that they can use it within their applications. Object-oriented development is the epitome of software reuse. In object-oriented development, an object represents a thing, a concept within our application. Those things have attributes or properties that define their being. We refer to that data that we enclose within this software construct as attributes or properties of the object. And we typically do not allow users of our objects to interact directly with the data. Instead, we define functions that allow certain behaviors of the object with which a user of the object can interact. So another advantage of objects is that they have a very clearly defined interface for their use. So if we're a user of an object that performs some complex task for us, then we can focus on building our application without concerning ourselves about the complexity of the implementation of the thing that the class is doing. The class will generally have a well-defined interface with which we can interact. And so long as we understand how to use the interface, which is simply function calls, then we can take advantage of the functionality of the object without really understanding how it is that it does what it does. So when we create an object, we say that we are instantiating the object. That is, we are creating an instance of the object. If we have a class definition, we may have many objects that are created from that class definition. The class definition creates in the PHP system a fully fledged variable type within the system. With object-oriented development, our thinking about software changes dramatically. It's a sea change, a paradigm shift in the way that we view software constructs within our applications. When we're designing an object for our application, we're in search of nouns, things that are in our system. Those things typically have behaviors. Behaviors can be described using verbs. At any point in time within the execution of the application, an object will have a state of being. And that state of being is defined by the values of the data that are encapsulated within the object. So a classic example of a thing, an object in an application, is a person. The object has data that defines it, and we've listed some data here that defines a person: age, height, gender, and so forth. Those are the attributes or the properties of a person object. Then the way that we interact with this object is defined in the set of behaviors that we as developers provide for that object. In this case, we provide an interface to each of the attributes of the object, the ability to set or to get the value of those attributes. That is the behavior of the object. Throughout our exercises and demonstrations, we've been working with a user and logging that user into our application. As an example of how we might create an object, we will create a user object that encapsulates the data and the behavior that we might need in our application. So recall that when we define the object, the class, for this user type, it becomes a template within our application from which we can create specific objects of type user. So some of the attributes that I'd suggest for our user class are the username and password, maybe a user ID, an email, maybe a secondary email, and the status of the user, whether they're an active user or inactive user. Some of the behaviors that might be appropriate for a user object is to log in, to log out, to send an email to the user, to change the user's status, or to log a user's visit to our application. An object definition is subjective. There is no right or wrong. So let's look at the syntax, the rules within PHP that allow us to create these classes for our applications. When we're defining the encapsulated data, the attributes and properties of the class, we have the same naming restrictions that we have with variables. And although not enforced by the syntax, a good design practice is to never allow direct access to any of the object's internal data. Therefore, all of the attributes or properties of a class should be marked as private, prohibiting direct access, which leads us then to defining behaviors. We want to define behaviors that make our object easy to use, flexible, and complete. When we're defining behaviors, we also have a choice of whether or not to make that behavior publicly accessible, that is, accessible by the user. There are occasions when we will define internal behavior for an object that should not be accessible by the user of the object, but is some function or some behavior within the object that we need to use to manipulate the state of the object, but not to allow a user to call that function. There's 4 steps to creating a class. First, we have to sit down, before we write any code, we have to sit down and think about what are the properties or attributes of this class, and what are the behaviors that I'm going to define for the class, this interface for the user. Then what access levels am I going to provide for this behavior? Then we need to decide how we're going to construct these objects. What is necessary to make an object of this type? And then finally, when the object is no longer needed, we need to define how the object should release any internal resources that it needs to release, and define a destructor for the object. Notice that PHP defines a constructor and a destructor for us. We don't have a choice of naming the constructor and the destructor. In PHP, when we want to provide a definition for how an object is to be constructed, what state it is to be in when it is created, we write a construct function. A construct function is 2 underscores, the word construct, and parentheses. The code block that follows the construct function defines how the object will be instantiated. What state will the data be put in when the object is created? And likewise, for the destructor, PHP defines this function for us, 2 underscores and the word destroy, followed by the parentheses. The constructor and destructor are both simply functions, but they're special functions associated with our object. The code block that follows the destroy function will be executed when the object is no longer needed. We would put code in this destructor method that would release any resources that needed to be released before the object is destroyed. So we've got a definition of an object, either ours or someone else's that we're using, and we want to create an instance of that object. We want to instantiate an object of that type. We have a new keyword, literally a new keyword. The new keyword tells the PHP preprocessor this is an object and we need to create an instance of this object. This is the name of the object, and here are the values that it needs to create itself. Go create it for me, and when you're done, give me a handle to that created object, and I'll store it in this variable. So we've kind of seen this already. If you'll recall from the demonstrations, when we were throwing a new exception, we were actually creating an object of type exception and then throwing that into the try-catch mechanism in our code. This is very similar. We are creating an object using the new keyword. The PHP preprocessor actually creates this software construct for us and then passes back a handle to that object that we're storing in this case, the myObjectVar variable. Now we want to interact with the object, the behavior in the object. We have another new operator. Although we've seen this before, in this case, the arrow operator, which is the minus sign and the greater than symbols, allow us to call the internal behavior of an object. In the example here, we have an object that has a function within it called do something. Now we've created the object with the new keyword, and the handle to that object is stored in myObjectVar. So using that handle, myObjectVar, and this new operator, I say call this behavior do something. Now again, we can control the accessibility of all of the internal attributes and behaviors of an object by using these three new keywords. An object would not be very useful if it had no public behaviors, so keep that in mind. But on the other hand, we want to protect the state of the object, to not allow a user of the object to be able to put the object in a bad state. So there are things that need to be protected, there are things that need to be public, and as the designer, as the developer of the object, we need to make those informed decisions. So the three new keywords are public, private, and protected. Any attribute or behavior that you adorn with the public keyword will be accessible to anyone that uses the object. Any behavior or attribute that you adorn with the private keyword will be inaccessible to anyone using the object. And the protected keyword will only allow access from a subclass of this type. We're going to talk about inheritance and subclasses in the next video. That's where the protected keyword will become useful. Here's our user class. The user class is going to provide the application the ability to create objects of type user. Every object that gets created of type user will have its own copy of the code within the class user. So we begin the definition on line 4 with the keyword class, followed by the name of the class. All of the code that belongs to this class is enclosed within opening and closing braces. The first thing we see inside of the class definition is the attributes for the class: username, preferred email, secondary email, user ID, and status. All of these are marked as private, which means that no one who uses the class will have access to these attributes. Because of the private keyword, these attributes, these variables within the class definition, are not accessible to the public, to any user of the class. On line 14, we define the function construct. Again, it's 2 underscores and the word construct. This function defines the process to be used for creating objects of type user. On line 14, notice that the construct function is declared as public, required. It must be declared as public so that anyone that wants to create an object of type user can do so by causing the call to the construct function. Inside the construct function, we take the arguments that are passed in and assign them to the attributes. So the construct method takes 3 arguments: a username, a preferred email, and a secondary email. Now notice that the secondary email has a default value. So someone creating an object of type user could pass 2 arguments into the call to create the object. They could pass username and simply 1 email because the second email will default to null. This provides some flexibility for the user. In any case, all of the attributes of the object are initialized. They're given initial values within the construct function. Note how the attributes are accessed within the class functions. We use the $, this variable, the arrow operator, and the name of the attribute. Notice that the name of the attribute does not use the $. The $, this variable, is a built-in variable that's provided to us by PHP for every object that we create. This points to itself. It is a handle to itself. Hence, we use it to access the internal attributes of the object. The syntax can be a little tricky, especially remembering not to put the $, before the attribute variable names. So pay particular attention to this. The next function on line 24 is the destruct function. Again, underscore underscore destruct. This function is called by the PHP preprocessor whenever an object is no longer needed in the system. In our case, we have no resources to release, so we're just echoing a statement identifying the object that's being destroyed. Again, these functions are all declared as public, which means that anyone can call them. Next, starting on line 29, we have a set of get functions. Now, this is typically the interface that's provided to allow someone using this class to access the internal attributes of the class. Again, a reminder, we don't ever want to give direct access to the attributes to any user. We cannot protect the state of the object if a user has direct access to the attributes. So we have get functions for username that simply returns the value of username. And again, pay particular attention to the mechanics for accessing the internal attribute from within the object. This arrow operator and the attribute name. We repeat this process for the preferred email and the secondary email and the user ID. And all of these functions just simply return the internal attributes value to a user of the object. Now, we've decided in the design process that there is no need to provide set functions for the username or the preferred email or the secondary email, and certainly not for the user ID, because these are values that are set during the construction of the object and should not be changed thereafter. An argument could be made that you could provide a function to update the preferred email or the secondary email. I'll leave that to you. However, there is no need to update the value of user ID or to change the value of username. So the only set function that we provide is for the user status. We allow a user of our class to set the user status. Now again, we are responsible for providing an interface to our object that protects the state of the object. So you should never write a set function that accepts input from a user of an object without validating the values that are passed in by the user, again, to protect the state of the object. In this case, the only valid inputs for set user status are either 0 or 1. So the first thing we do on line 58 is we test that input. The input must be 1 or it must be 0. It can be nothing else. And if it is, we return false and do not change the status of the object. If the value is 0 or 1, then on line 62, using the this variable pointing to ourselves and the arrow operator, we access the attribute status and we assign the input value to that attribute. Then we return true to the caller. The key to creating a class is on line 4, the keyword class followed by a name. Everything gets enclosed in opening and closing braces, and everything within the class definition must be adorned with either private, public, or protected. Then we must define a construct function so that we can control the creation of an object of this type. The construct function will ensure that the object is created in a valid state. The destruct function is optional. We are not required to define a destruct function. However, it's good practice to take control of the destruction process of our objects. Whether or not there are resources to be released, we want to keep control of our object. So let's look at our helper function. We're calling the helper function on line 20 to return to our constructor a user ID. Now the user ID must be unique in the system so that every user has a unique user ID. So let's look at this helper function and how we achieve that. Very simple function. Function getNextUserID takes no arguments, declares a static variable initialized to the value 1. Remember that the static keyword says that this variable will live throughout the calls to this function. So it has a lifespan across calls to this function. And then we increment the value of user ID by 1 after we send the value back to the caller of the function. So in this call on line 20, we will always get an incremented value for the user ID, ensuring that our user IDs are always unique. So let's see how we can create now one of these user class objects. Well, the first thing I do is I require the inclusion of the user class.php file on line 8. And that's a cascading inclusion because when I include the user class PHP, it will include the helpers function itself. So now I'm going to create a new user on line 10. I create a variable called Picard, and I say, assign to Picard the handle for a new user object. And here are the values that I want you to use to construct that object. Then on line 12, I simply echo the values within that object. On line 16, I create a second object and I assign the handle to that second object to the variable Ripley. When I create this object, I am passing in 3 values to the construct function. Now, I don't call construct. It is called for me. That's managed for me by the PHP preprocessor. The syntax is for me to use the new keyword and the name of the class from which I want to create an object. Within the parentheses following the class name, I pass the values that the PHP preprocessor will pass to the construct method. Again, I don't directly call construct. The PHP preprocessor does that for me. On line 17, I do a print R to dump the contents of the Ripley variable, which will be a handle to a user object. And then, simply to demonstrate another function we can use to see the contents of an object, on line 19, I call var dump and pass the Ripley variable into that function call. So let's see how this works. So we'll see the output from our collection of echo statements on line 12 through 15. Then on line 17, I call print R on the Ripley object. And similarly on line 19, where I call var dump, I get a dump of the contents of the user object. And notice that the information provided by var dump is more detailed than what's provided by the print R. And then finally, the last two lines output are from the destruct method. Recall that in the destruct method of our user class, we said, when you get called, when this function gets called, print the username associated with the object, this, whatever the current object is, print the username, and object is being destroyed. So what we see is that both the eRipley and the JPicard objects are automatically destroyed for us when the application terminates. We may find a class that provides 80% of the functionality that we need for our application. In order to use that class for our application, we may decide to augment the existing code that defines the class. However, this may impact other users of the class. To avoid this, object-oriented development provides us another option. We can inherit all of the attributes and functionality of an existing class. We can augment the functionality within our class and even add attributes within our class while taking full advantage of the functionality and attributes of the class from which we're inheriting. In the object-oriented world, the class from which we are inheriting is known as the base class or the parent class. The class that we're creating that is inheriting from the parent or the base class is known as the child class or the subclass or the descendant of the parent class. Object-oriented development allows us to reuse and extend an existing class for our own purpose without affecting the original implementation of the class. So how do we create this parent-child relationship? In PHP, when we define our class, we use a new keyword called extends. When we say this class extends and the name of another class, that tells PHP to take all of the content of the parent class and include it as part of the content of this new class. Then anything we add to our class augments that existing functionality and that existing set of attributes. And depending on the accessibility adornment of the parent class attributes and methods, we may have direct access to those within our subclass, our child class. Within the child class, we get direct access to anything in the parent class that is declared either public or protected. The protected method is defined for use in these inheritance hierarchies. By definition, protected accessibility means that the public has no access to either those attributes or the functions. However, any child class has direct access to those attributes or functions, methods within the parent class. Often we may want to change the behavior of the parent class. For example, the parent class may have a function named myBaseClassMethod that has some behavior. And in our child class, we would like to redefine the behavior for the function named myBaseClassMethod. We'd like to give it other functionality. To do this in the child class, we simply create a function with the same name. When a user of our class then calls the function myBaseClassMethod from our class object, they will execute our class object's code associated with that method, not the parent class code. However, there are circumstances where within the child class, we may want to access the functionality of the parent class method within our override method. To do this, we use the keyword parent and 2 colons, parent : and the name of the base class method that we're calling. This tells the PHP preprocessor that we want to go up the hierarchy chain and execute the code in the parent's function of that name. So let's go look at some code. To demonstrate inheritance, we're going to use the classic object-oriented example of the person class. The person class is defined on line 3 using the keyword class. The name of the class, in this case person. The body of the class, the code that defines the class, is enclosed in braces, beginning on line 4 and closed on line 30. Everything between those braces belongs to the class person. On line 5 and 6, we define 2 attributes of the class. They are both adorned with the private keyword, meaning that they cannot be accessed by any code outside of the code defined in the person class. On line 8, we've defined a construct method. This is the constructor for the person class. When our application creates an object of type person, this is the function that will be called to create that object. And this function takes 2 arguments, person's name and ID. Notice that on line 8, the construct function has no access specifier. By default, if no access specifier is included in a function definition, the function is public. Again, by default, a function is public if no access specifier is provided, which is okay for our construct method. We want it to be public. Notice inside of the function block for our construct method, on line 10, we're calling a function string to lower, str to lower. This function simply takes the value of the argument person's name, converts all of the characters to lowercase, and returns that value, which we assign to the private attribute name using the this variable and the arrow operator to access that attribute. Again, pay particular attention to this syntax for accessing attributes within a class. Then we take the ID argument and assign its value to the national ID attribute. On line 13, we have a public function getName that simply returns the value of the name attribute. On line 17, we've defined a function setName that takes an argument newName. The function is adorned with the protected access specifier. The protected access specifier tells the PHP preprocessor that the subclass has access to this method, otherwise the method is private. And in this method, we convert the argument newName to uppercase using the str to upper function and assign that value to the name attribute. On line 21, we define a function setNationalID that accepts an argument called ID. Notice the adornment on this function. On line 21, final and private. Private meaning that this is inaccessible to any code outside of the class. Final tells the PHP preprocessor that this function cannot be overridden by a subclass. And there is no code associated with this function because it's our design decision that once the national ID is set, when a person object is created, it should not be allowed to be changed. On line 26, we have a public function that returns the value of national ID. Get national ID simply returns the attribute value. Now, to make use of this person base class, we've created a class employee that will inherit from the person class. On line 32, class employee extends the person class. It's going to inherit all of the data, all of the functions of the person class, and those that are protected or public, it will have direct access to within the employee class. Anything that's marked private in the person class, the employee class will not be able to access those functions or attributes. The only way the code within employee can access the private attributes or functions of the person class is to call the functions that provide the interface to those private attributes. So the definition of the employee class includes two private attributes, employee ID and department. Then we have our constructor on line 37. The construct method, again, with no adornment for access specification, which means by default it will be public. The construct method takes three arguments: employee name, national ID, and department. When our code creates an employee object, part of that creation of the employee will be to create a person object as part of the employee object. So our code needs the arguments necessary to create the person object. In this case, employee name and national ID. So on line 39, we call the constructor, the construct function for the parent class person. Notice the syntax: parent : and the name of the function. This tells the PHP preprocessor, go to my parent class and call this function. In this case, we're calling the construct function, and we're passing the arguments necessary to build a person object. On line 40, we assign the return value from a function call to generate employee ID, which is a function that belongs to the employee class, because we're calling it with the this variable and the arrow operator, and it returns a unique employee ID, which we assign to our attribute employee ID. We take the department argument and assign it to the department attribute. On line 43, we've defined an accessor function, setName, a public access function, setName. Now notice that setName is the same function as what we've defined on line 17 in the parent class. So the setName function in the employee class on line 43 is an override of the function in the parent class. In our case, we're simply calling the parent version of setName within the override in the employee class. On line 47, we've declared another final private function called setEmployeeID. Again, final tells the PHP preprocessor that this function cannot be overridden. Private tells the PHP preprocessor that no code outside of the employee class can access this function. And again, our design decision is that once an employee ID is assigned, it cannot be changed. We have no code implementing this function. On line 52, we have a public function to access the attribute employee ID. On line 56, public function to access the department attribute. On line 60, another access function to the department attribute. And on line 64, we have a little helper function for our employee class. This function is final and private and generates an employee ID. Again, final telling the PHP preprocessor that this function cannot be overridden in a subclass. Private telling the PHP preprocessor that this function is only accessible from within this class. On line 66, we declare a variable as static. What this tells the PHP preprocessor is that there is but one IDGen variable for however many objects of type employee we create in our application. There will always ever only be one variable IDGen. It is shared among all of the objects of type employee. And then we increment that value and return it to the caller. To create objects of these types within our application, we use the new keyword. On line 9, I've included the file that defines the classes. Then on line 11, I create a person type object and pass it the values for the arguments that its constructor requires, a name and a national ID. The return from the construction of the person object, the handle to that person object, is stored in the MacReady variable. Then we do a var dump on that variable. Then we create on line 14 an employee object. Now, the employee object requires 3 arguments in its constructor, 2 of which are passed directly to the person class constructor, and the third is used to assign to the department attribute. So on line 14, we create a new employee with 3 arguments passed to the employee constructor. The employee constructor, in turn, passes 2 arguments to the person constructor and then assigns the value for the department, which is the 3rd argument, and assigns a value to the employee ID with a call to the getEmployeeID function, then returns a handle to the newly created employee object, and we store that handle. We assign it to the Roy variable. Then we dump the variable on line 16. On line 17, we create another employee object. When that object is created, its handle is passed back and stored in the Inara variable. And on line 19, we dump that variable. So let's see how this runs. Reload the page, and we'll notice that object 1, the first var dump, is of person type, and we get a list of the attributes of the person type along with their access specifier. So we see that the attribute is name from the person class, and it is a private access specifier. Its value is RJ MacReady, and it is of type string and size 13. The only other attribute of the person class, the national ID, also private, is an integer whose value is 1, 2, 3, 4. And then we dump the 2 employee objects. Employee ID is a private attribute of the employee class of type integer whose value is 1. Now recall that The employee ID is populated using a static variable in the class, which means that that variable only exists once for all instances of the class, and that we increment that value after we return from the call to the function getEmployeeID. So our first employee object has a value of 1. We would expect that our next employee object has a value of 2. And certainly it does. Here is our second employee object. And again, the value of the employee ID attribute is 2. The only way a user can interact with our class is through the public functions we define for that class. Those public functions provide the interface for the user to access the class data and behavior. So it's important to provide both a useful and a complete interface. And once we publish this class and it's used by other developers, we want to avoid making any changes to the interface. Adding public functions to the interface is okay, but making changes to existing functions will likely break any application that's using our class. And we always want to protect the state of the object. So we never want to provide direct public access to any class attributes. Also, in defining our classes for our application, keep in mind that inheritance defines an is-a relationship. An employee is a type of person. A car is a type of vehicle, so that the subclasses become specialized versions of the base classes. And again, maintain the focus of your object. An object should do one thing, and it should do that one thing well. So now it's your turn again. In exercise 9, we're going to ask you to create a movie class. And in this movie class, we'd like to have the attributes title, year, director, and rating. This is the MPAA rating, G, PG, PG-13, R, and so forth. Provide an interface for your class. Then create a web page with a form that will allow users to enter information about their favorite movies. And finally, print the user's movie information.
If you're not a subscriber, click down below to subscribe so you get notified about similar videos we upload. To get the course exercise files and follow along with this video, click over there. And click over there to watch more videos on YouTube from Simon Sez IT.